Test. Hello. Oh, there we go. Testing. Testing. There we go. Okay. Okay. Ooh. Talk down like that. All right, we'll figure it out.
Good? Okay. All right, good morning. Thank you for coming to the DevOps track. I'm Josh Corman. I put together a track of 5 different talks today, so you can come to them a la carte, but I wanted to at least frame that if you intend to see the track as it was intended, who we picked and why we picked them. So we're going to kick off the day with one of the luminaries and pillars of the DevOps community. He's also behind DevOps Days, and that is John Willis. Who at the time was at a different company, but now I must point out that he's at Pacific Crest Securities. But he is one of the central thinkers, philosophers, promoters of the positive patterns of DevOps. And what we really want to do is for a lot of security people who are either afraid of DevOps or reluctantly embracing DevOps to hear it from the horse's mouth, where it came from, intended to be fairly independent of security. Following John, we have David Mortman, who's a security and thinker, but also a DevOps and automation speaker and writer, and I hate to say thought leader, but I'm going to say it. So that's going to be a really nice way to transition between, so what does DevOps really mean for security people? Not the FUD, not the sunshine, rainbows, and unicorn poop, but means. A good intern Edwards, who's really helped a lot of people get started on their DevOps journey. And that's going to be like, if you're just getting started, what does it look like? And how do people tend to get started, and where do they go from there? And then if you're really good at this, we asked Chris Swan to come in because he's doing some advanced stuff, like how do you make products based on DevOps toolkits and tool chains like Docker. And that's both going to show the glory and the horror of what it means to security. In some ways, it makes it in other ways, it makes it much, much better. But the reality is people are adopting these technologies and these philosophies, so we have to embrace them. And then to close out the day, we really wanted a practitioner's eye view. So we have Matt Tesaro from Rackspace, who's fully embraced this and had his lessons learned and his bruises and scars. And that should help you round out a real practitioner perspective on all that. So again, DevOps Foundation, DevOps myths and facts and fiction for security, getting started with DevOps, getting advanced with DevOps, practitioners' full embrace and case study of DevOps. So we really hope that you enjoy the day, and without further ado, I'll give the mic to John.
Great. Thanks, Josh. It's funny, you know, I'm not a security guy, right? So I do a lot of these presentations these days. I spent a lot of time in the network space over the last year in DevOps and networking. I have to start up with I'm not a network guy. So, and then somewhere along the way they get that I kind of understand the space. But I've been kind of reluctant to be a security guy because there's just so much. I know David, me and David work together, and I know Chris Hoff a little bit. And I realize, you know, there's something special there that I have to learn a lot about before I should even get up and try to talk about things. But the thing was, in the keynote this morning, it was interesting how relevant a lot of that discussion is so in line with the things that Damon, who's another good buddy of mine, we've been talking about. We do a DevOps Cafe podcast together. Going through some things I didn't agree with them, but for the most part, it was interesting how relevant mine and Damon's story is to what's going on, even though it wasn't. That's my start off. So I'm John Willis. I'm Bocce Gloop on Twitter. I'm currently an executive in residency, which actually just means the world is tilted off its axis. The fact that I would have a title that has the word executive in it and working for an investment bank. But it's really more of an entrepreneurial holding ground for kind of startups for another thing. So think about an EIR for a VC, very similar to that. So quickly, I'm going to do kind of a little introduction, tell you about what I've done and why I was invited. I'm going to do a quick DevOps overview. I call it the who's to blame. So a little bit. I'm not going to tell you much about DevOps. In fact, I'm going to show you one slide, and I'm going to say that's the best DevOps. But I'm going to then talk about who's to blame, and then go through like what did we get to where people are now every conference now has a DevOps track, you know. And then I'm going to talk about kind of like what I think is relevant of what I've been talking about, which is kind of software-defined everything. So to me, if you buy at this point and you think it's a nice pattern to doing things for security, for software, for network, whatever, then I would say that the next place that we go is kind of a software-defined everything, and the underpinning that would be the DevOps of everything. Make sense? And you can smile, you can laugh. I might cuss, just getting you. I don't know if this is a cussing conference or not. Go for it. I won. All right. So here's the thing about DevOps. We could spend the next 4 days, week, arguing about like DevOps is this, and if you remember, right? We had the same argument about that, right? And I'll tell you right now. I mean, I think you're going to get a really good explanation from David, and in the whole day. But I think you get a lot more to see the view from, especially from this really led the DevOps security, in my opinion, story. And then Damon, you know, has a really good story. But so all I'm going to say really about DevOps is what Adam Jacobs says. You know, this is the fallback position. It's a cultural and professional movement. Full stop. You know, I lied. I'll say one more thing. It's a metaphor, right? Like, in other words, what we started out with, DevOps. There was a wall, and we really just wanted to solve that. And then people say, well, should we call it sec DevOps? Should we call it sec this? You know, it's a metaphor. There's a broken communication between two groups. In the keynote this morning, it was clearly security and developers, right? It just the people who started this thing were really concerned and how bad the relationship was glaring above all in our eyes between developers and operations. The wall. Collaborate. How do we break that wall? So I think a better way to kind of follow through is, how do we get here? If you hate DevOps, these are the people you can go beat up. Okay? All right? So don't beat me up now. Okay. You know, actually is Patrick DeBar. So Patrick DeBar was in Belgium. He basically, as a software developer that was this problem of being a smaller infrastructure where you don't have large ops and you don't have large dev, and he went around starting asking, hey, is anybody trying to solve this problem? And discussion going on, operations, agile infrastructure. Actually, in the 2008 Agile conference, put out a BOF request to see if anybody wanted to talk about agile operations. And I saw Damon get pissed. I think that's one of his slides. There was one guy, Andrew Schaefer, is a good friend of mine. He was one of the founders of Puppet Labs, and like nobody showed up. You know, I don't remember if Andrew did the BOF and Patrick showed up, but nobody showed up. But they knew it was a good idea, and then O'Reilly in Europe, and O'Reilly's like, go do it yourself, and he basically created this conference called DevOps Days, coined it, and I actually had the opportunity to go there. I was working for Canonical at the time with their cloud effort, early cloud effort. Evangelism. It was amazing. In fact, next month we're having our 5th year anniversary. It's going to be a big event. You know, it's a big deal. But to follow the Patrick thread, I was at that, again, I came back, I was doing a podcast with Damon. We were like talking about how do we bring this has to happen again in the US. And so me and Damon kind of cooked up the how do we get a DevOps Day conference in the US. There was other people that helped, but me and Damon kind of drove it. And so if my role in DevOps, I've been an evangelist, I've been a believer of it, I speak about it. My probably biggest contribution was that we started the first DevOps Days in the US in 2010, right? Yeah, 2010. And it was a huge success. 300 people showed up. So that's kind of one thread. Along those lines, there was John Allspar, who is also thought of as another real leader in the DevOps movement. He worked for Flickr at the time. And I think it was in 2008, he gave a presentation, 10 deploys, to, kind of like, oh my God, 10 production deploys a day? Up in the back of the room like, this can't happen, my God, the world is ending. I mean, we've heard stories now doing like 1,000 deploys in an hour, right? And that's not a litmus test for DevOps. So it's an idea that creates a flow mentality. Iterative processing, all these things. And so John really started this whole thread, and he was a big guy in Velocity. He was an author. He was the author of a book called Web Operations, which actually is a really good book if you want to understand the mindset of what everybody was thinking in web operations around 10-ish. And there's some great chapters. In fact, Eric Ries wrote a chapter, Patrick DeBar wrote a chapter, Andrew Schaefer wrote a chapter, Jesse ran all infrastructure for Amazon, was there. So you've got kind of the John Allspar thread, which becomes the O'Reilly Velocity thread. So I apologize to y'all for not getting to see Jez. But Jez, what's funny, I used to do this kind of history of DevOps, and I published an article called DevOps. I left out this really interesting thing that in 2006, Jez Humble at ThoughtWorks and a gentleman called Chris Reed and Continuous Flow, and they presented it. They had a white paper, and they did it at Agile. And so they were already talking about this kind of, this doing SDLC, and so I think they deserve a lot of credit because ThoughtWorks as a consulting company has done a lot to promote the DevOps story. Deeper. How many people have read 4 Steps to Epiphany? Has anybody even heard of it? People have heard Eric Ries, Lean Startup. Okay, I was hoping to be more. But yeah, so a lot of people, Eric Ries was a student of Stephen Gary Blank. The difference like 4 Steps to Epiphany and Eric Ries was that Eric Ries actually did a startup where he tried to implement a lot of the ideas. These were things like minimal viable product, customer discovery, all those things. And Eric Ries has been very famous because he started out with a blog startup where he implemented, and again, there's this flow idea, process, right? And not just for software delivery, but software delivery and operational. And we even as software developers got agile and they were moving fast and working very iterative, the ops people were still in a waterfall. So there would be this handoff of the artifacts that were ops people be like, well, we can get that one in November, we can do January. Extreme pressure for operations to deliver faster. And to give Eric, you read Lean. And actually, Jez Humble now is about to publish an enterprise, Lean Enterprise, right, which he's taken that forward. But Stephen Gary Black holds the kind of what I think is the beginning point of that thread. And then how many people have heard of Chef and Puppet? Of course. Okay, good. Now I probably would have left if nobody raised their hand. I'm out of here. This is not going to work. All right. So if you go back 20 years ago, there was a gentleman called Mark Burgess who wrote something called CF Engine, who basically implemented all the core concepts of Chef and Puppet, item potency, all these things, right? And you can read. The problem was he was an academician, and Mark's a good friend of mine. And he didn't give him usability. People started adopting this like and even early days were implementing his. Luke Canese of Puppet Labs was a power user of CF Engine, hated the user interface. This is a really short version. And he decided to write his own version of CF Engine, implementing all those core concepts that Mark Burgess did. Became reasonably successful, and even today very successful from a start. And Adam Jacob, code, he basically frustrated Puppet user, more about not but scale and order and cloud infrastructure drove him to have his kind of breaking off of why I have to write. But the lineage is absolutely clear. In fact, I learned the order, and I kept like thinking, oh, Adam Jacobs a genius. He thought of this and this. And then I learned Puppet, and like, oh, Luke Canese did that. And then I learned CF Engine, and I realized Mark Burgess actually kind of. Finally, last but not least, most people know me, hate the fact that I always have to use Deming in every gentleman called Edward Demings. And I'll give you the shortest version I possibly can, but this man is on DevOps. It's unbelievable. So short version is, Deming was a physicist who basically got into kind of management ideas, fell in love with the idea of statistics, was actually the first one to implement statistics in the Bureau of Labor Statistics in census analysis, still used today. Some of his management and quality techniques were used during World War II, where he was credited for winning the war for some of his techniques. After the war, this is where it gets interesting, he gets sent over to Japan to rebuild Japan, right? And he institutes his ideas. And in 1950, at a summit, he tells they have 80% of the wealth of Japan room. And he tells this room, if you implement my ideas in 5 years, this country will be successful. In 5 years, almost to the date, they are successful. But folks, Deming is the Shakespeare of Toyota Production Systems, Lean. Follow that thread. Lean came over here, with G and Lean IT, all that stuff, right? And Lean is a cornerstone of DevOps. So, in other words, Deming is the DevOps. And so these are the people that you can blame. Unfortunately, you can punch every one of those in the nose anymore. So that's kind of where, DevOps is about collaboration, breaking down walls, whatever works. There is no that's wrong. And when you hear that, the person who's saying is wrong. So the more interesting thing to me right now, this idea of DevOps, and I think you'll get more from David and David and gang later about what's going to happen back there, more about DevOps, what it is, and all that stuff. But now I'm going to talk about kind of what I think we need to do in DevOps, and I think this is a part where it may or may not. So there's always these marketing terms. Cloud is a marketing term. DevOps is now becoming a marketing term. DevOps started out not as a marketing term and has resisted that, but now it is co-op. It's been co-op by all the vendors, right? But SDD is a marketing-driven term. So is converged infrastructure. And so converged infrastructure is about basically network, storage, and compute given to you, right? And so that was all the rage a couple of years ago, where vendors were converged infrastructure, and we've got your converged infrastructure. In fact, UCS from Cisco is a good example. Stuff, the collaboration, that stuff, and there was tons of vendors, right? Now the problem is that these were first order, this is like a first order abstraction concepts together, right? Because they were all coupled to hardware. right? So a converged infrastructure implied that I get this, the network and the storage, and it's all great, and that's probably awesome. And so VMware, I think, would get credit for creating this buzzword around SDDC. I'm more interested in the opportunities and the possibilities. So to me, what SDDC, Software Defined Data Center, means is a converged infrastructure idea, stay with me or leave, that is taking this converged infrastructure to a second order abstraction concept. So if we think about the components here that are defined under Software Defined Data Center, we have, again, compute, storage, and network. Compute is easy. First order abstraction of compute is basically taking a physical machine and making it look like multiple machines, right? 101, virtualization, easy. Storage, a little easier. First order abstraction for storage is taking a physical a storage device, carving it up to look multi-tenant. You got network virtualization. Networking, interesting enough, first order abstraction is this thing called a VLAN. Taking a network device, making it multi-tenant, looking like multiple networks within one box. What are the second order abstractions in all three of these? The second order abstraction is what we loosely call cloud for compute. Something like OpenStack, hate it or love it, is a second order abstraction for compute. Because now you're decoupling or disaggregating the request of the requester from the hardware. Like now, the concept of cloud is we have hypervisors on hypervisors or controllers on hypervisors that dole out, and now the whole idea of somebody requesting compute is free or disaggregated from the actual allocation of that. Storage, what we see there is things like Ceph and cluster and object storage, S3. I think those are clear indications of second order abstraction of storage. Object storage is a great example. There are good other examples. But I need a blob of storage somewhere. And nobody administratively, other than making sure the object store cluster is working, has to go and physically configure anything for a particular place of where that object's going to get allocated. And the place that I've been really excited about in the last year has been my network space, which again, I think is a second order abstraction of the VLAN concept. VLAN, I physically have to go to a network device and put in VLAN here and put a VLAN A, VLAN B, and say, okay, these are now going to be this logical network, but very first order. When you start talking about software-defined networking and things like overlays, and probably the most popular overlay now is VXLAN, right, is this idea that I've completely decoupled the virtual network abstraction. It is truly a second order abstraction. So when the keynote speaker, and I forget his name because I'm not part of this, and even if you told it me, I'd forget it again, but he would say there are no perimeters. I would say the perimeters are quantum. They come and go. They're virtual. They list. They exist. They go away. They're kind of hard to trace. But that is what SDN is really bringing these cold overlays to say, you know what? I know you got switches. I know you got Arista. I know you got Cisco. You got all this crap. But all I'm going to say is there's a virtual instance here, virtual instance here, and a virtual instance here. And here is the network that they consist of, and nobody has to update any physical hardware devices to do that, right? And by the way, if system A needs to move over here, that's fine, because the virtual, sometimes they just go away and come back 3 hours later. So to me then, the DevOps of everything is the opportunity is that we've been myopic on compute. So the problem with DevOps today is 99%, 95% of the conversation about DevOps today is about compute. If you think about Chef and Puppet and now Ansible, they're all about perimeters. If you go see any DevOps Day conference, you'll see most of the discussion is about provisioning, configuration on a post OS or virtual instance. Sometimes about storage, very little about network. Although, interesting enough, I actually asked David, will I offend anybody if I don't add the fourth tier here, which would be security? And in general, I think the common, or converged infrastructure is that security falls under compute in one way, and it falls under network in another way. So SDN, how do you get fire from an SDN discussion? Data plane of an SDN, and I'll go through software-defined network in a minute. But the point is, they're the global picture. James Wickett, and I'm sure a lot of other people involved in this, has done a job of being an evangelist, like Rugged and his Gauntlet project, right, and things like that for security. So again, I want everybody to start thinking about what is this DevOps thing. If I'm buying into it, first off, let's start beating the shit out of the people who talk about compute all the time and tell them to stop doing that, particularly if it's your data center. If all the oxygen in your data center is about compute and DevOps and compute, like, and you're a network person or a security person, like, whoa, whoa, whoa. We need to think about this globally. Like, we need to think about what are the primitives across the board. There's a guy called Derek Carlson who actually was he was one of the architects at TIBCO, and then he went on to create Cloud Foundry, and now he's got his own startup that's been in stealth mode for like 3,000 years. But the presentation about what we should be thinking about now as an industry is this idea that there's this packet or metadata, that says, I'm an application, this is what I need. I need this amount of vCPU, I need this amount of vMemory, I want my kind of network perimeter, virtual and ephemeral, or even quantum if you want, to look like this, right? And so I'm going to specify that off to some implementation that takes that interface definition and equally distributes those for the application. This is far off stuff, but we're scratching a lot of, and we're way too far in compute, way less in network and storage, and certainly, and again, I think it's a good place to fill the gap really well in this kind of SDDC model. Am I full of shit? Make sense? What? Couple of thumbs, couple of nothings. So how many people are familiar with the concept of software-defined networking? This is the way I explain it to the rest. We got one. We'll see. Well, then you can tell me if I've done a good job or not. I won't make you come up here. So this is, and there's a lot of views on it, software-defined network. There's also there's some debate on how it should be, and you could obviously see Cisco and VMware, but that's all by itself. But in general, there was this gentleman called Martin Casado. And again, just like earlier, I put first-order names in the list. They're the only person who did this whole job by themselves. It's just a kind of an anchor for where to get started on the discussion. But this guy, Martin Casado, worked his PhD in something called OpenFlow, or in general is credited to the mission of SDN. He formed this company called Nicira. They got a for $1.2 billion. You don't work for Nicira, do you? Good, okay. Basically, no production customers, really no revenue, $1.2 billion, and everybody like, what is this SDN thing anyway? But I think there was some magic there, and I still believe that SDN is pretty awesome, despite all the marketing bull crap and all that. So what SDN in principle is, if you look at network devices, switch, route, switches for network pretty similar these days. They basically have three planes. In the classic legacy implementation of network devices, you had three planes, control plane and data plane. Data plane, simply packet in, packet out, wire speed. It's the brains of how data moves from where, and how it gets to the next place and how it gets to the next way. It's basically the internet, right? The control plane, more interestingly, is the brains, the distributed brains at a slower speed that populates the data to make those decisions. Those decisions that get generated by the control plane have historically been created by router protocols. BGP, OSPF, those things. And as brilliant as they are in terms of distributed computing, and I always say that in order to be able to build an abstraction of one of them, you had to have been born in 1940 as a computer scientist. The problem was they work brilliantly, they run the internet. In fact, sometimes they break the internet. Like, didn't we run out of TCAS tables recently? Which, but the point is, the brilliance behind the people who have written those things is basically why the internet and everything is so successful. The problem was they were incredibly hard to abstract. Right? You really, and so in a lot of ways, it was almost like this magic. I basically said, I got BGP in this route, I got this BGP in this switch, and you magically distribute and make things happen. And most of the times, things happen the way we wanted them to happen. And when he didn't, it was hell. And what Martin Casado suggested was that I'm going to go ahead, I'm going to take that control plane out of the device, I'm going to put it up in a place, kind of a distributed store, and make it more malleable to normal people that weren't born in 1940 and understood like intensely complex mathematical computer science algorithms, right? And because all he wants to do then is put something, and this is a simplistic model, it's a lot more complex than it, is build a matching table for packet in, packet out. And that gets distributed down the control planes. And so the protocol, not the only protocol, but one of the more popular protocols of take and match table that actually then distributes down to data planes was OpenFlow. Only one. I think Chris Hoff almost killed me one day because somebody suggested I said it was the only one in a presentation, so I go out of my way every time to make sure I times. But anyway, again, this is a lot more complex in implementation. Companies like VMware's NSX have done a making humans put policy that this gets translated into that then gets distributed to do really cool things. And I'll tell you about the cool things here in a minute. Is a really interesting open source project following the OpenStack kind of history or flow. And then there's companies called NewEdge and PlumGrid, and there's lots of people who are doing reasonably well in the enterprise. But here's where it gets interesting. So in router protocols, it was sure packet A, when it comes in here, goes to that port to go out. So hopefully to get to the next hop, get on guitars.com, I somehow get to the right place, right? The problem was the logic in there to do like maybe start consolidating firewall rules and actually doing some of the firewall definitions in the data plane were going to be really difficult to rewrite BGP and OSPF. When you put a very abstract policy level on this, and so again, whether this flies with a network person or not mine to argue, debate. But I will tell you right now, VMware is going into large corporations, basically selling this idea of IP table sprawl, firewall sprawl, to move it into, and in fact, VMware calls it the Goldilocks zone. You might want to take this idea of the Goldilocks zone as the hypervisor being the perfect place to actually implement. But it doesn't stop there, right? So if you buy into the fact that not only can make arbitrary decisions of packet in based on data I see, but more complex decisions about I can actually start implementing firewall rules in this data plane. I actually can start it's unlimited to what I can do from a policy perspective to start changing the flow of data. That is, folks, why people are very excited about SDN. It is also why Nicira got bought for $1.2 million. On the open source side of this story, the most interesting story is Open vSwitch. So this is the virtual switch data plane base. This is so it's not the physical. And you'll find is this is kind of lingua franca in non-ES cloud implementations as the virtual switch. So, and just to go over the overlay, the virtual network, I talked about VXLAN a little bit earlier. So now very popular on these virtual second-order abstractions and what people are doing to build kind of virtual networking. So in other words, I don't really need to worry about, like from the hypervisor, I don't need to worry about the actual physical connection, like what switch is on, and then go in and define the switch to define its relationship with the virtual. So if you take the lower left-hand corner virtual machine and the upper right-hand corner machine, I can actually, by policy and driven, that population control plane pushes it down the data plane, can build that logical construct so that the instances can get to each other. Configurations, right? There are some other popular overlay protocols. So I mean, what else is driving this software-defined everything? We've got this disaggregation of hardware and software. So there's things like called bare metal switches. Cumulus Network actually just sells you the network OS, and you go out and get your own hardware. It's very disruptive. Arista kind of started this. They still sell you the hardware, but they're mostly and they're very malleable. These are operating systems. Arista is basically CentOS. Cumulus is a Debian distribution. You can bash into the device. No longer do you have to go in and run expect scripts. You can actually go in fact, a lot of these are Python driven, so they're very abstractable from. So think about all the security network config. that you guys may or may not be dealing with every day. Now you can do things, now you can take a look at Chef and Puppet and think an Ansible or blah, 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 as many as you want to go down the list. You can start thinking about how can I actually move from a world. I totally disagree with the key. Everything is the right way to do. I think it is a software world. I think Andreessen Horowitz is absolutely correct that it is, that the software is eating the world. I agree with the keynote on how to deal with software. And so that means software-defined everything means everything should somehow probably repository. Probably Git is the greatest answer and gift to us over the last 25 years because it forces us to collaborate on how we work. And so now if everything we do, from network config, from the stuff that James Wickett's working on with Gauntlet, from the stuff that goes into network configs to the stuff that goes into virtual, we're all starting out as source repository stuff. And by the way, when we change it, we have a natural collaboration collision, something called a pull request, that forces us to collaborate this. So in the network, people actually storing network configs in Git, that request an automatic change going through Jenkins, and in Jenkins running things like either Ginger or ERB templating to fill in the blanks and go out, pull JSON data to pop Cucumber. I'm trying to get James to add to Gauntlet some of these network tests, right? So that then you can actually questions on site. And by the way, most of these new vendors like Cumulus and Arista and even Cisco now have really cool virtual implementations, so you can actually run a virtual network that is a full leaf-spline structure, so that by the time it gets there, you can do some type of behavior-driven test. And so everything we do should probably be stored and kept in that manner. And probably getting close to the end of the time. So again, the software-defined everything, the DevOps, if you're buying into this, what I think the software flow should look like, I think if we accept that software is eating the world, then we should start thinking about abstract hardwiring config definitions. I mean, that's what Chef and Puppet were about in CF Engine. It was like, back in the day, somebody went into a config definition system in a certain place and brought the system down. And the idea was, there's no guarantee that you build an abstraction to do that, but it's safer, it can be tested. Let's learn from what our software brethren have done, right? So I think the opportunities here, there's some other we need to think about. I said I want people to rethink declarative, not just compute. It should be network storage, it should be security. Again, security's done pretty far there. So, but here's the core of any DevOps discussion is, you know, me and Damon are credited for coining this phrase called CAMS, culture automation. It's a loose, I mean, we actually did it on a podcast where we were thinking out loud, and it actually turned into something, and we didn't actually expect it to become a loose taxonomy for DevOps, but it kind of is. So we call it CAMS, culture, automation, measurement, and sharing. And what we say is, if you don't get the culture right, and it's going to work. And so if you watch any of the discussions about DevOps and all the things that the people who fail and the people who win, people who win get this culture. Many presentations on culture. Damon has done many presentations on culture. If you just go to any of the DevOps days, incredible information about how to deal with culture. If you get that right, you kind of have brilliant fun because you get to automate. You get to in your job. I always used to tell people it's called the 80-20 flop, right? If in your job 80% of your left that just God darn it, and 20% of your time is like, hey, you did a great job, or you really feel like you're moving the needle in your organization. I will tell you that the sell I've been selling for 10 years in DevOps is about flipping that. And that most of the people who I know adopted these concepts now will tell you that 80% of their day is about moving the needle, and 20% of the day is about muck and how do you do that? It's repeatability, it's just all those things. So some quickly, like how do you, in an SDC world, how people thinking the same way, tools that we've used in the software, sysadmin, I'll just generally call it compute. You know, something called value stream mapping work really well for kind of software delivery in a full DevOps or operations driven. I've been recently using this model for network config definition. You know, infrastructure as code, I think works. It's a great concept. It should include other things other than just operating systems and applications. Continuous delivery is a reality. I think I've talked about that. The flow. Jez Humble has a great book on continuous delivery. I think Kanban is a great operational tool, even if you're in network, security, compute, any part of data center, any kind of IT operations. Kanban is an incredible agile tool. One of the things we've done very well in DevOps. So how do you get DevOps in security? Well, how did we get DevOps in original compute? We basically use this tool of many, this idea of embedded engineer. We took an ops person, we actually physically moved them into a development team. And that person spent a year in that team and infused ideas. And oh, by the way, wait. When you guys go to create directories here, if you just went a little different here, it would make life so easy over there. Right? So why not, if people are not thinking about that in security, why not? Maybe take an ops person, put them in security. Put a security person in ops. Put a security person in dev team. I'll tell you what, the Facebooks and the Googles and all that, they got these teams called SRE teams. Like they're watching over stuff. I mean, I know you know most of this, but the point is they know this. They've known this for 4 or 5 years. Google, Facebook, Twitter. It's the way they operate. Peering, I do think everything should be in Git. Sorry, kill me. But everything in Git request is a peering opportunity. Hey, somebody's got to review this peer request. I think people just sitting down and peering. I met Joe. This is common in software delivery. I'm going to be working on this project here. Is there any chance I can get you to sit down with 3 hours? This is great. Now, what does that mean? Enterprise has got to have buffer time, right? So the whole theory of constraints, Gene Kim's very popular in this community. There's a rewrite of a book called The Goal. Elliot Carrot wrote The Goal. The Goal, at core concept, is something called theory of constraints. Core concept of theory of constraints is actually making sure you put in the things you do. So when your boss says, "Ooh, yeah, Susie going to work for Bill on a peering project, that's going to kill everything," your boss is clueless. But you need to have those buffers. I've got 5 minutes. I think hack days. So again, and I'm guilty of this. I used to run a lot of hack days that really were cute. I go to a DevOps days, we run a hack day, and all we're doing is like a bunch of compute stuff. And I'm using compute generally for systems administration, data center. But like, why aren't we having hack? Have the security folk, the network folk, the marketing people, all in the same room, and let's try to solve big problems. How many people are? Quite a few, right? Fair enough. Like, it was developed in a hack day at Facebook, and Facebook never actually wound up using it. Her Netflix. Netflix core architecture is built on, if you watch a movie, thank those people at the Facebook hackathon who just decided to create this different type of data store, because you wouldn't be getting your videos properly if it wasn't for Cassandra. Whatever. Have fun. Hey, if I tell this to network people, your network on the 6th floor and their cubicles have coffee stains and it's just mucky and it just kind of stinks. Route them to the 14th floor, put video games, Nerf pistols. Like this stuff should be fun, because go visit a Star weeks ago, and I've watched them go through 4 offices now. And it was fun. You walked in the door and everything about that place was fun. Ping pong apps. And most start buzz, just walking in the door. And I know those guys. I've known Luke when he was a one-person company. And even I got a little, like a little, like it felt good in my heart to feel that. Anyway, I'm basically time. I think abstraction, I think polyglot, people learning multiple languages in whatever field you're at. The keynotes basically expressed that. I totally agree. Integration tested, behavior driven. You in any type of data center or IT infrastructure discussion. In summary, there's a lot of opportunity. Embrace the software. Embrace the concept of software defined everything. VMware, when they say yes, yeah, I get it. I know what I need. For that, I know DevOps Cafe, me and Damon have a fun time interviewing people, just about all subjects. Hearing me this morning.
Okay. I can turn off gear too, that's fine, so that way. Okay, you'll go left. It was pretty awesome. There wasn't a Do I sound good? Yeah, I'm on. Do I sound good?
There you go. All right. So the next speaker is David Mortman. He's a longtime security guy, but he's also kind of established street cred and experience in automation and instrumentation, and has really been banging that drumbeat for quite some time that it's not so much that we need blinky boxes and anti-APT kitten killing devices, it's that we need to do the basics better. We need to reduce the operational entropy and have more predictable, stable environments. And as such, he's kind of become a tribe where usually the panels are you, me, Gene Kim,
others.
There's about 5 or 10 of us trying to promote. A lot of fairly scared security people, but the trick is there's basically the people who are afraid of DevOps and hope it never comes to them. The people who are going to wait to deal with DevOps, and the people who've really embraced it and had breathtaking results, and I think David falls into that category. It really swallows the beast, so we're going to try to debunk facts and fiction, and the legend is actually him, and DevOps are rivaled only by his skills as a baker. So, David.
Josh. So, the idea of this talk started because I hear a lot of concerns about security when you start dealing with DevOps. And mostly, honestly, there's some facts in there, but mostly it's myths, so I'll talk a bit about that, what the actual facts are. But mostly we'll talk about the myths and what you should actually be concerned about versus what you shouldn't be concerned about. So, as Josh said, I'm David Mortman. I'm the Chief Security Architect for a Dell product called Instradius, otherwise known as Cloud Manager. That's all you hear about the product today. I used to be the CISO at Siebel Systems. For anyone here have to use Siebel software in the past? Anyone? I'm sorry. That's all I can say about that. I'm sorry. I'm on Twitter as Mortman. I'm a baker. I have a pizza oven. If you want to talk baking afterwards, let me know. Has nothing to do with DevOps whatsoever, but it is tasty. So if you're into gluten, talk to me afterwards. So before I dive into our actual first thing, who here is actually familiar with DevOps, has to do DevOps on a regular basis? Okay, a pretty good number of folks here. So I'm not going to dive too much into what DevOps is. For people who weren't at the previous talk, John Willis gave a great sort of high-level definition about what DevOps is about. But at a really basic level, DevOps is about working well with your peers, both within your group, whether it's DevOps, security, networking, whatever, but actually working well with everyone, having actual empathy for your peers and what they're going through. Gary McGraw sort of talked a bit about this, I think in his keynote. He had this whole thing about the security people who walk into the development environment with a big report from one of these security tools or a penetration test, and basically throwing it on the table and laughing at the developers, or being the jackbooted security cop. That's not an empathy there either. Whether you go in with anger or glee or anything else, if you're not going in with a sense of partnership or trying to get things done, you're actually shooting yourself in the foot. I will confess, I've been doing security for almost 20 years now. I have been the jackbooted security thug showing up to engineering telling them they're doing it wrong. And I can tell you, it doesn't work real well. It doesn't make friends, it doesn't influence people. So that's something to definitely think about. John really, in the previous talk, talked about the importance of culture. Culture matters. It matters a lot. If you have a culture where there's an adversarial relationship between security and the rest of the world, it's really hard to get things done. You've probably all noticed that. And so transitioning from a culture of no, or you suck, or you're stupid, to how can we make things work really makes, at least has made my life a lot easier. And the need for things like Zantac has gone down a whole lot as a result of being a mellower individual. There's a lot to be said for that, but that's a different show, so we'll have to save that for another time. The first myth I want to talk about is that there's this huge idea out there in the security space that DevOps breaks separation of duties. And this really is driven by this idea of organizations who let developers push code to production. This flips people out to no end. They're like, developers pushing code into production? I learned in Security 101 that developers should never be allowed to log into production and make changes. And the fact is that when you talk about DevOps, what people talk about really here is some sort of automated deployment mechanism, whether it's using a Jenkins or some other continuous integration tool or a home-built tool to push code from production. I have yet to talk to a shop where a developer is physically logging into each server and pushing code live. That would in fact break separation of duties. But let's back up a little bit. I sort of got ahead of myself. What are the goals of separation of duties? What is the goal of having an operations person deploy code to production? There's two goals. One is the idea that, well, whoever's pushing the code to production will validate that that code is secure, that the developer, the evil, malicious developer, has not coded a backdoor into this stuff that's being pushed to production. Who here validates the code for security vulnerabilities before they push it to production if they're on the operations side? No hands. And you know what? I do not know of a single organization who attempts to do some sort of code review or reverse engineering on patches that they get from their vendors to determine if there's a backdoor in that code. And it's just, it's a void point. The point, as the old SNL routine with Jesse Jackson, the point is moot. No one does this. This has nothing to do with DevOps. This has nothing to do with engineers versus ops folks pushing things to production. The real concern is change management. Change management, this is actually a real problem. How do you know what went into production, when it went live to production, and who pushed it to production? These are serious, real security and operations concerns. Now, it turns out that the typical change management process when someone wants to put a patch into production is they may get some level of approvals or not, depending on their organization, and then someone goes ahead and pushes it to production. And then they go to their change management system and says, I push the following patches to production. If I remember to actually go to the system and do it, or something like that. Versus your typical DevOpsian automated patch deployment system says, David pushed the following patch or the following lines of code to production at 10:38, and 38/100ths of a second on this date. And so when there's a problem, we actually get much tighter change logging of what's going on. And so as a result, we're not actually breaking separation of duties. If anything, we're enhancing it because still no one's logging in. It's an automated system. So in fact, what you have is you still have individuals can't make unauthorized changes. And to the extent that they can make authorized changes, what you're looking at is where the approval flow happens. So when you have automated systems, you are approving a much larger range of actions that someone can take ahead of time. So even in the strictest change management shops I've worked with, like dealing with nuclear reactors and things like that, there's a certain level of things that people are pre-approved to do. They can create users, they can lock out users, they can make certain levels of access rule or firewall rule changes without having to go to a change management board. All we're doing here is broadening the range of things that someone is authorized to do in an environment before having to get to a human approval system. So no, we're not breaking change management. We're not breaking separation of duties. We're just doing it differently. Nothing wrong with different as long as you understand what's going on. Myth number 2, DevOps ignores security. Well, this is only half a myth. This is actually also a fact. The myth part is, and I'll get more into this in some later myths, is that just because you are doing DevOps doesn't mean you don't have security. Where security happens shifts. Just like when we went from waterfall to agile, where security happens shifts in the organization. You no longer in a DevOps world have a defined gateway of security. And much like in agile, you don't really have as much of a defined gateway point of security where a security person can stand there and say, I have manually run the following tests. I assert this is allowed to, this has met the magical bar. This is PCI, this is HIPAA, this is whatever. You're allowed to do the next step. You have to get into automation. And I'll talk more about automation in a little bit. And in that sense, there are opportunities in DevOps to do security. But where its fact is that DevOps is happening, and you have an opportunity as a security person to be part of this equation, to be involved with the discussions, with helping automate security testing, by making sure that there's security-oriented unit tests and functional tests and integrated tests, and working in security products like the Vericodes and the White Hats of the world, where you can Qualys. I mean, the number of people out there on the show floor who have been API enabled so your automated test systems can run these tests, can validate that your product is secure enough for your needs, that they meet your bar for security to go to production or go live or whatever your requirements are. This is here. This is an opportunity for security people to embrace DevOps and move on and continue to be relevant to this discussion. And I think that's an important thing, is that this is an opportunity here with DevOps for security to remain relevant. There are organizations who, if we insist on remaining the gateway, insist on doing things the way we've done things in the past, they will ignore us. They will just go, they will do their thing, and we will in fact be left out in the cold. So this is actually only a half myth here about whether or not DevOps ignores security. I have to say, I think this is my favorite myth, actually, which is that continuous deployment, continuous integration means less secure code. The idea that code is going to production faster and more readily means that our code is less secure. And this could not be farther from the truth. There's some awesome research that's been validated repeatedly, but it started in 1979 at IBM Research up in Watson. And what the research demonstrated repeatedly was that as your feature set gets more complex in a product, in your software, the code gets exponentially more complex. Now, code complexity is it's a fact of life, but it's also one of the major factors that leads to security issues. If your code is the more complex your code is, the harder it is to identify security issues, the more likely it is that you're going to create a security issue, particularly once you get into the sort of business logic end of things. It's harder to track things down. It's harder to debug. But what this means is that if you do a series of small changes rather than larger blobs of changes, your code ends up less complex. It's a little basic algebra, but it comes down to that fact. So so there's just that. If your code is less complex, it's easier to debug. It's less likely to have security vulnerabilities, less likely to have bugs in general. And you end up with a more stable, more performant, more secure product as a result. Furthermore, the smaller your change sets, the less likelihood that any one change set will have a security bug in it, and the less likely it'll be that security bug, if is the kind of thing that will take down your site. Now, the cool thing when you start getting into these continuous deployment products out there, you push a code change, and it runs a bunch of automated tests on it, and it'll come back and say, David submitted the following 50 lines of code. He broke the following sets of unit tests or other tests. This is the line of code where it broke on this test or this series of tests. So suddenly now you have a very fast feedback loop. So you get to issues. You can identify issues before they even go to production. When you create an issue, you're now doing a build that minutes after you created the code, not hours or days, which means you're in the thought process. What was I thinking when I wrote that code? There's some the period between something, and them going back and reviewing it. It was for them to figure out why they wrote it. What were they thinking of the process? What was the goal of what they were writing? What were they trying to say? Well, it turns out this research also applies to the longer the time span is between writing a piece of code and having to go back and fix it or make changes to it, the harder it is to figure out what you were thinking. The context switching problem gets harder and harder the longer the time span is between writing a piece of code and having to deal with it again. So if you can get incredible feedback because you're only making a small change and you get those unit tests back, you can actually respond to broken code faster, which means your bugs have a shorter lifespan, and it's easier to fix the problem and less likely that attempts to fix it will fail. So this is all good stuff. But then, should this bug make it to production, and bugs make it to production all the time, the smaller your change set, the easier it is to troubleshoot. You can say, oh, hey, I pushed 25 lines to production, and the site went down. I wonder what are the odds that that change is in more of those 25 lines of code? No, it could be that it's an interaction problem that's with some older code, but still, you have a pretty good targeted point where to look. And generally speaking, as long as you're avoiding things like schema changes, rolling code back out when it's a small change is significantly easier than rolling out a really big change. I mean, think about the difference between making a change to a configuration file or a router ACL versus applying a service pack to an operating system. I mean, it's much easier to fix a small change, roll back a small change. So so I kind of drew this out a little bit. The point is that the smaller your change sets, the less complex your code, the less likely it is to have vulnerabilities or other kinds of bugs. And if there are, the easier it is to troubleshoot and respond, which means less downtime, which means faster. Not only do you have less downtime, you have faster. You have less downtime in general, and when you do have downtime, your ability to get back up is faster. So you have, which is all good for your metrics. Your executives are happy that way. Your customers are happy that way. And what you end up with is a system that, even though you're changing it more often, is actually more stable. It's sort of counter to the general idea, and this is why when your system when you're making a lot of changes, your system becomes less fragile. It's less problematic to be making changes versus sort of the old school system way of dealing with things where we had very reliable hardware and not that reliable software. We wrote software for the enterprise, the Siebels of the world, the Oracles, the SAPs. We have pretty stable designed to run on some serious hardware that's incredibly stable, and folks like my company and others design hardware that is supposed to be ultra reliable because they know the software on top of it's not that reliable, honestly speaking. As we migrate to cloud, we're talking commodity hardware. Mean times to failures are a lot shorter, so the software has to become more reliable. And so you can't say, oh, my software's kind of, you can't get away with fragile software. You have to have solid software, which means changing it counterintuitively more often to get more stable software. I see a few confused faces. Are there questions about this? Okay. Myth number 4. DevOps and ITIL don't mix. Who here has to deal with ITIL? I'm even more sorry than the people who had to use Siebel. No, ITIL is not really a problem. ITIL is a really solid process-oriented way of doing business, especially on the IT side. It's service management, it's change management. There's nothing inherently bad about ITIL. Where ITIL becomes a problem for organizations, especially smaller organizations, is that it's very bureaucratic. It tends to have lots of meetings, lots of paperwork, sometimes literally on paper still, but it's process heavy in a bad way. There's a lot of, it's not very agile. There's a lot of opportunities to spin wheels, to have a lot of bottlenecks. There's nothing actually in the ITIL specifications that requires the bureaucracy. The bureaucracy is a holdover from the days, I mean, this stuff was starting to be built in the 80s. It was holdover in the days when we didn't have a lot of automation, where computers were expensive and people were cheap, as Gary McGraw said in his keynote. There's nothing in ITIL to say you can't automate things, and there's nothing to say that the bureaucracy has to be there. So DevOps actually came out of, the term was coined, and the ideas behind it were first formulated by Patrick Dubois and others at an ITIL conference. And related to that is there's this myth that DevOps has no process, that people can just do whatever they want, whenever they want, wherever they want. And that's actually really far from the truth. DevOps relies a lot on automation, and automation is another fancy way of saying process. But the big difference between traditional DevOps, I mean, to the extent that there's any tradition in DevOps yet, and ITIL is that there's almost no bureaucracy in a well-run DevOps shop. There's a lot of process. Every DevOps shop I've talked to is process insane. They love their process. They want to know that they're doing the same thing the same way every time. That's all process is about, is consistent performance. ITIL is about consistent. Six Sigma, another dirty word in our industry, is also all about process. DevOps and ITIL and Six Sigma, these all play well together, conceptually speaking. At a philosophical level, they're not actually that different. It's all about how we actually do things, how things are getting done on a day-to-day basis. So process, like I said, process is really about getting things done consistently the same way every time. Automation, whether you're using a Chef or Puppet, I love them, but the awesome thing about these tools is they help remove the human element from issues. People are really bad at doing the same thing over and over again, the same way. We're not good at repeating things consistently. They are really good at repeating things consistently. So I would much rather automate everything I can. I'm lazy. I would much rather have a computer push those, when I'm deploying my software, my team software, we deploy it in our SaaS environment to like 8 web servers, and I have no idea how many app servers these days in our database clusters and things like that. I don't want the ops team worrying about logging into each server manually and worrying about did they deploy everything the exact same way at the same time. They use Chef. No, it's quite possible that they're going to screw something up in designing the Chef cookbook, and as a result, it will be deployed improperly to all the servers. But at least it'll be the same way, which means that when I'm troubleshooting a problem, I can fix one server, and once it's fixed, I know how to fix all of the servers. I'm not standing around going, I have 12 servers here, 3 of them are acting this way, 8 of them are acting this way, and the 12th one is acting a completely different way. Well, which one's the right one? Is any of them the right one? Back in my Siebel days, when we started pushing Microsoft patches within 24 hours of Microsoft releasing them, because the attitude I came up with was that we'll deploy the patch on a couple of test systems. Does it blue screen? No, we're good to go. Now, it's quite possible that Microsoft will reissue a patch. But it's also quite possible we'll get the next SQL Slammer, Code Red, Nimda, whatever it was, and I would personally rather break the network in a way I understood that I had broken it, rather than a way that I had no idea what the heck was going on. And that's really, in a sense, what these configuration management systems are about, is you broke things. You're going to break things, that's fine. When you talk to the folks at Etsy, it's sort of if you're a developer and you haven't broken the website in the first week or crashed the website, then you're probably not doing your job. People are kind of look at you funny. It's sort of a badge of honor to have done that. So now process doesn't also mean no, DevOps doesn't mean no bureaucracy. So Facebook released, now, and they've updated now with a fabulous video presentation of how they do release management. And they're a very DevOps-oriented shop. So they have, 10,000 developers now? I have no idea. I lost track. They have thousands upon thousands of developers. They have a release management team of 3 people who manage their entire release management process because they've automated a lot of things. And in order for code to go in production, every single code you write at Facebook is manually code reviewed. Doesn't matter if it's security-oriented code or not. Every bit of code gets code reviewed by a colleague. Has to be done. A little bit of code that you commit repository for the entire Facebook site. And so it's big. Goes through an onslaught of automated security testing and performance testing and whatnot as well. But it doesn't automatically deploy to production. There's a release management team who actually manages that release cycle. So there's a little bureaucracy, but there's still a lot of automated process. In order for your code to go live in production, this is really cool. You log onto the internal IRC server, you authenticate yourself to the bot and say, here I am. I'm ready to go live as a developer. If you don't check in, I've windowed the release management team. It doesn't matter who you are. It doesn't matter how important to be logged into the system to say, I'm ready to support this code if it breaks something. Even in spite of the code reviews, even in spite of the automated system, you just missed your window. You get your next window, and it could be a week. Because the risks, of breaking something at a site of that magnitude are a problem. So some companies have a little more bureaucracy than others, but again, not mean no bureaucracy. Doesn't mean no process. It doesn't mean you can't do ITIL at the same time. It's just where the humans end up in the process shifts a lot in your organization, what your exact needs are. Auditors hate DevOps. I hear people, oh, I can't do DevOps, my auditors won't let me. Have you talked to your auditors about DevOps? Did your auditors just magically show up and say, oh, okay, you can't do Agile. You can't use PHP. Well, actually, that'd be a good one. No, you can't use JavaScript. There are auditors who will, when you say we're doing DevOps, because they don't understand it. This is not inherently a problem. It just means that you have some education to do to explain where your actual are and saying, look, you're used to seeing this control as a manual process. Here's how we've automated it. Here's how we're validating it. Here's how we can show an audit trail around this. Anyone here doing infrastructure security in the early 2000s? Okay, so there was a handful of folks. You remember when your auditors would show up and you'd say, hey, I'm using Qualys. And your auditors would say, whoa, how do I know? I need to run a scan myself. And a bunch of us spent a lot of time working with our auditors to explain to them how Qualys worked and how we didn't actually have the ability to remove results or alter how things were. And we could show them, here's the report we configured to run, here's the results, handed off to the auditors. And the auditors said, oh, I just showed how old I was. Or to be using at the time. And so there's an education problem. Auditors don't hate DevOps. They don't hate Agile. They do like PCI. They do love our regulations, but there's nothing here that says you can't. You could build a DevOps environment that doesn't actually demonstrate the things the auditors want to see. And you know what? They'll tell you what they want to see, and you can make that happen. But in terms of the big thing here is change management, as always with auditors, and the tools, the chefs, the puppets, the CF engines, and the related tools do a much better job of auditing than we do. And they have the added benefit of that if everything has to go through your CI engine or your chef or puppet, it means that you also see the unauthorized changes. You know, if a employee is misbehaving and says, I'm gonna go ahead and create a local user on this machine, so I have a backdoor in, they're not going to go to the change management system and say, hey, I put a backdoor in. That would be kind of foolish, and it wouldn't make them a very good miscreant, would it? However, if they go into Chef, because that's their only way of making changes to the system and deploy a new user on the systems, it's there. It's easy to audit. It's easier to see what's going on. And these tools, the chefs and the puppets, have an added benefit of that they actually have tripwire-like functionality. Anything that's being managed by those puppet manifests or those chef recipes, basically, the says, whoa, someone just logged into the and change to the database. Well, I'm managing the database. That change is unauthorized. It puts it back to the way it thinks it should be, much like Tripwire does. So you get a little added security that wasn't sort of in the advertised scope of what's going on there in terms of your configuration management. Your configuration management systems, your auditors love this, they become a CMDB of sorts. Anything that's managed by your chef or your puppet is now a CMDB. You can say to your auditors, whether it's from the BSI or whatever, or they want to say, well, how many machines are running Oracle 11 GR2? Well, I go to Oracle, I go to Chef, and I query the database. I have 12 servers running Oracle 11 GR2 with the following hotfixes that I pushed. Oh, and by the way, I can tell you that it took exactly 68 minutes for all the following patches to push to Linux across my environment. And I can tell you that actually I'm only currently at 98% compliance because this box is not checked in recently. Can you do that with your current tools? Maybe, maybe not. Certainly if you're not running a big fix or some of these other tools, sort of a second generation product like that, if you're doing it manually, you certainly can't do that. So no, auditors will like DevOps. One of the things you want to talk to when you're dealing with your auditors, when you interview your auditors, especially from some of the larger firms, is understand who you're getting. In a lot of cases, when you start dealing with the really big audit firms, if you get sent a, shall we say, less experienced auditor, fresh out of training, they may not have the authority to accept something new, or they have their checklist. They're only allowed to follow their checklist. That's what they're allowed to do. And so when your auditors come in, before they come in, when you're negotiating the scope of work, find out who you're bringing in. Find out if they have the authority to even listen to you about, what are your compensating controls? How are you doing things outside their level of expectation? And if they don't, insist on getting, or at least a member of the management team for those auditors who has the authority to sign off on compensating controls, who understands what compensating controls mean, things like that. So it's not an inherent thing. This is not a black or white issue. Auditors, the ones I've worked with, once I explain DevOps to them, are like, that's really cool, because it is. And I call this fact number one. Actually, it's now, I guess, fact one. I talked earlier about DevOps and security and ignoring it. We can't ignore DevOps. It's coming. It's here. It's the trend right now, especially for a lot of organizations. So it's definitely one of these scenarios where we can get on board or get run over. sort of blindly saying that you're not going to accept DevOps is kind of like blindly saying I'm not going to accept Agile, or I'm not going to deal with PCI or any other regulatory framework. It's here how we interact with it. Understand, ask your organization, what do you mean by DevOps? What are you trying to do? What are the goals here? I mean, DevOps, like I started off, is a philosophy. It's a cultural phenomenon, like John said in his talk in the last session. So understand, what does DevOps mean for that organization? What are they trying to do with it? And take the opportunity to be part of DevOps, even if you don't agree with it personally. Thank you very much. Any questions?
Yeah, so I totally got tripped up on how you asked the question correctly. So if anybody in Ops we actually do review everything for the release. It's just we're not Ops.
Right.
But what I was going to ask is I love the whole thought of this, and I really do want to embrace it. I see a bigger problem that I would love you pointed out some resources on how do you culture change to get the developers and the QA people to accept it. Because I think the security guys run to it.
Right. I mean, how to convince people to do something they don't want to do is sort of one of the great management problems of all time. One of the things I found when in organizations I've worked with, DevOps has actually been pushed by the development organization. But in the cases even where it wasn't, the idea of going to folks and saying, hey, this is an opportunity to work on the hard problems and not have to do the same grunt work over and over again. Like John said in the previous session, there's a Pareto principle here, the 80-20 rule, and the goal is to migrate from it being 80% grunt work to it being 80% fun work. And when I talk to folks, whether it's in security or ops, I say, hey, let's just automate a few things here. Let's talk to each other and understand where the problems are. And people are like, they want to do it. I mean, the thing is, no one likes doing writing the same lines of code or the dev side if it's sort of especially a lot of startups, it tends to be the same function. It's like, I see a lot less of this rhetoric now, but there used to be a lot of rhetoric around developers don't want to write secure code. Most people enjoy their jobs, and they want to do a good job at their things, and they get really bored doing the same stupid shit over and over again. And the culture on DevOps really helps towards orienting towards getting rid of as much of the grunt work as possible by automating it.
All right, good afternoon. We have 2 of our 5 DevOps talks done. The next talk, so this morning, if you were with us, we had John Willis, who is a pure DevOps guy, very active in the DevOps days, kind of give us a hurricane tour through how DevOps sees the world, independent of security. Followed by David Mortman, one of our own, who's been very active in security, but has really been an early adopter of DevOps patterns as a way to get more stability and repeatability and automation and take human error out of things. And now we're going to go back towards the middle here, which is Damon Edwards, who's also one of the co-hosts of the podcast for the DevOps Cafe. But more importantly, the way I got introduced to him was through Gene Kim and his book, Posse, for the Phoenix Project. In that he was really a Sherpa guide helping people start their DevOps journey and get from nothing to some of the early positive patterns. So we're really pleased that now that our worlds are colliding, we're starting to have more partnerships and collaborations and crossovers with security. And I think this will be a great place to see how do we take it from fiction or theory into actual practice. And stick around for Chris Swan to advanced integration and technology stacks being built out of some of these toolkits. And then at the end, we'll bring it our Rackspace, who is actually using these things in practice as a security and ops guy. Thanks.
Thanks, Josh. Can everybody hear me okay back there? Sounds good? Yeah, great. So, the point of my talk is, there's these DevOps going on inside organizations, believe in it or not. It's an opportunity for happening. It's an opportunity for get inside of the DevOps transformation companies, what we see going on across the industry, and part to make yourself more relevant, and also for your own self-interest, your own goals, right? What do you want to accomplish and achieve? So that being said, let's get started. Josh, at Twitter, on Twitter, at Damon Edwards. Also do a podcast, which is a lot of fun. It's kind of like a very unprofessional, not very well produced Charlie Rose. John and I do this long form interviews where we get people from really all walks of life in kind of related to this DevOps world. We've had CEOs, we've had folks like Jez Humble, who've popularized continuous delivery. David Anderson, the founder of Kanban, founder of Puppet. Patrick Dubois over there. Sean Porter, Sensu monitoring guru, the IT skeptic. So we really kind of do this long interviews where we find all about what they have to know and offer the world, and it's gotten kind of popular. So we hope to more security in the future. So shoot us an email or just subscribe on iTunes and tell us in the comments what you think. So my kind of view of the world, or how I got to be standing here today. A couple of things. So, I'm kind of a lucky person. I get to see the industry from a lot of different perspectives. I already talked about the DevOps Cafe stuff that we did. We get to just interview and talk to people from a community perspective. But from a work perspective, I'm a co-founder of 2 companies. The original one was DTO Solutions, automation improvement company. Now does a lot of what's called DevOps. And really got known for helping big enterprises translate all the cool stuff they were seeing at conferences. How do we break it down to first principles and translate it to something that actually work for us, right? That was a lot of culture and kind of organizational dynamics consulting, and a metric crap ton of automation. I'm a co-founder of another company, a company called Simplify Ops, that was built to put services and tooling around a open source project called Rundeck, which is freely available. You can go check it out. I'll mention where that fits in later. And yeah, so because of those 2 things, I get to see a whole lot of interesting views of the industry. Caveat, I am not a security expert. It's not the point of my talk. The other people will talk about security. I'm here to learn about security from all of you. I'm here to talk about the process. We straddle process improvement, we straddle culture. And I like to say, we're outcome guys. Outcome, I mean, in every business, there's this core process, right? It's from a business person's head says, I got an idea, to manifest itself as some type of customer outcome that we can measure, hopefully through getting more money, right? So that's what I mean by outcome. I'm most interested in how do we improve that process. And really, going back to, if you go back to what the lean manufacturing folks said, right? What's this about, right? When they want it, and at the lowest cost possible, right? And really in order of importance, right? Make sure we got the right fit. They've got to be make sure they've got it when they want it, make sure they've got it at the lowest cost possible. And yeah, it seems straightforward, right? But obviously, this is, so cartoonishly, we tend to divide those camps up into the dev camp, the people that are incentivized to make things, to create things, and the ops things, protect things, keep things going. And obviously, we know that, there's all sorts of things in between, right? Security's not on there, QA is not on there, performance isn't on there, networks, there's a lot of things that take place. But cartoonishly, we talk about the world in terms of ops, right? So, but what happens is as we start to specialize this, as these cross, we have different functions, tooling, different career paths, different interests, and these silos, both implicit and explicit, start to form between these different areas of talk about. We mean DevOps problems, right? It's the bottlenecks, it's the risks, it's the inefficiencies, it's all the stuff that's going to get in the way of happening, going from an idea to running feature in a customer-facing environment, right? So this Jesse calls this in a nutshell slide, right? So really all DevOps is about saying how can we remove those barriers, those risks, those bottlenecks, those inefficiencies, so shorten our time to market, shorten our lead times, so we can get faster feedback to the business, get faster, and that faster feedback is not just from the holistic perspective, but also individually. How do we give developers faster feedback? How do we give the ops teams faster feedback? How do we give security teams faster feedback, right? And all that bundles up to we can give customers what they want, when they want it, and at a lower cost if we do it right? So now I think what makes DevOps unique is that it's really just an umbrella of ideas, and it's not a technology thing, it's not just a process thing, it's not just a culture thing, it's all of those things, right? Because in order to really make those outcomes happen, we need to be thinking across all three of those lines, right? And from the business perspective, it's time to market and quality, right? Every day. In the security world, we think about quality quite a bit, right? It's quality, I guess, or security being an aspect of a product's quality. But how often do we think about time to market, right? And how often do we think about our effect on the rest of, or our being? I'm now talking like you guys. So I've been here for 2 days. How do we work on our effect on the rest of the organization? So. More kind of background here. So the signals that the organization is getting better, right? How do you look at your organization and say, oh, we're going to try some of these new ideas. We want to get better at this, right? Well, how do we look at our capabilities actually improving? There's really 4 things that we see are probably the best indicators of if you're doing a good job of this stuff. Sorry, I was holding up 3 fingers. 4 things. First is lead times, right? That's not just the end-to-end lead time, which obviously is the ultimate goal, how fast from an idea to where it's in front of a customer, but more importantly, across the entire organization. What's our lead time on delivering environments? What's our time on turning around security fixes, right? Or security scans, whatever it might be. Are our lead times, number 1, dropping? And number 2, are they becoming more predictable, right? It's a pretty easy thing for us to measure. That's probably already exists in some project management folks, company today without doing anything new. Getting a little more interesting here, mean time to detect, right? So how quickly can we detect there's actually a problem? And that's not just, again, service level, but also at the more local level. How quickly can we detect that I made a change and it's not right? How quickly we could check that, hey, these 2 versions are each other, right, when we go to deploy them, or things like that. So lead time to detect, how quickly are we able to detect things is a sign of, time attack, right? Monitoring, do we have things broken down well enough to where we understand correlation, cause and effect, those type of things. Mean time to repair, right? And there's really 2 aspects to this. There's mean time to resolve, which is like, oh, I got the service back up. Right? Meaning, how quickly can we get something from, I know that's broken, and I got it working again, but or I did something to put a Band-Aid on it. How quickly can I drive that to get it fixed? And last one here, probably the most unusual, is this notion. So in the manufacturing world, it's easy to see this notion of scrap, right? So when you produce something that's not fit for the next person in the assembly line, that's called scrap. Either parts don't fit together, it's not quite what they expected, it's the wrong quantity of it. The most popular one we see in organizations is provisioning servers, right? How many times do you ask for, I need this environment, 2 weeks later, hey, here it is, you log in and you're like, crap, this is all wrong, right? And say this doesn't work for me, I can't log in at all, or this is missing this, or I got to go re-image, see people re-imaging their own servers. That's all scrap because you weren't ready to do because the people upstream from you provided you with something that was incomplete. So number one, we want to see less of that throughout the entire organization. So less scrap is the most important, but almost as important is scrap, right? I didn't catch it until we try to do a production deployment, or is it I caught it at check-in, or is it I caught it in my IDE, or where do you catch that? How far of the mistake did the error get before it was caught? And close that is to 0 or 1, right? That it was actually caught by the change. So we're doing, and the more competency we have internally. So when folks are saying all these DevOps, kind of end of the day, your life, you should be be able to measure these things and see your life improving, right? So some other folks are, why DevOps, right? If we just ignore it, these ideas, do we really, curious. And this is good to leverage. This idea is look at previous than that, the whole constraints. Everyone's talking about is how we learn as a company. How quickly can we move, adapt to the market to beat our competitors? So the latent demand's already there for the business, and I think what happened inside technology is say, let's make our lives better. People started writing about this, and vendors got involved. Hey, this is actually tapping into this, and we see, the analysts got involved as well. So you see this kind of landslide of hey, technology answer for these problems we're looking to. Obviously, conference nuts on the idea. Really, if you want to blame somebody, this presentation just kind of blurred out there, but Nicole Forsgren Velasquez, I always mess up her name, I apologize, and Gene Kim, author of the Phoenix Project, they put together this study they called the 2014 State of the DevOps Survey, right? So, they got respondents, 100 countries, all across these different industries. Half had more than 500 servers, half had less than 500 servers. So all of companies, and they asked about, and they really got down. Oh, so I should probably say Nicole. She's a business professor. She's in the IT industry, really statistician. Teaches at Utah State. So there's real academic rigor behind this. It's pretty startling companies that are doing these practices that we now know can be categorized under these DevOps ideas. And they found that these hybrid are getting 12 times faster mean time to recovery, that MTTR stat I was talking about before. So that alone is cool. But then it gets really nuts. They looked at these 10,000 companies and figured out that those that are at these high performing IT are now known as DevOps profitability, market share, and productivity goals. And they have 50% higher market capitalization growth over the previous 3 years. So, at that point, business people's heads, they got their attention, right? So, saying that, hey, that means, but it's going to give us the capability to learn faster than our competitors. So, bottom line, it's here to stay, right? So, we deal with it. So, what does that mean for us, right? Again, I'm saying us because I've been a part of the security tribe for a couple days now. And, is it an opportunity? Is it a, what do we, and I think the important part is knowing that, all the dreams, everything that security wants to achieve in an organization, as this board is being kind of redrawn, now's our opportunity to reset that relationship and figure out how, as the organization, how to put ourselves in right place. How do we talk the language of the people that are going through this process? Because for whatever it is, they've got the ear of the business, and they're getting the funding and the mandate to go and do it. And as also John mentioned this morning, there's going to be a conference in October, the DevOps Enterprise Conference. Whether or not you want to go is up to you, but it's all so global banks, insurance companies, manufacturers, large companies. All about, not about selling stuff, but purely about, hey, here are the techniques we're trying, and here's what's happening. It's going to be like 100 or so different 3 days. So this is a chance for us to for security to reinsert itself, right? So got to think about, well, what are people trying, the driving mindset that's going on here, right? And I think when you come down to the core of it, it's the realization that silos are of throughput. A silo is anywhere you have to have a handoff. Anywhere that somebody does something and then I need to hand off something off. They need to reset their context, receive what I have, and then go and try to make sense of it and do something. Throughput automatically drops and quality automatically drops, right? That's where those handoffs are where we see the #1 source of miscommunication, misunderstanding, being incompatible. Most critical part of it is not just it's slippery and difficult, complex, but it's all, right? The farther you go to the left, the more application knowledge they have. And as you cross those silo boundaries, drops off very quickly. On the same way, the operational knowledge goes the opposite way. The far right got all the knowledge about how stuff works and what is being deployed to those least amount of context. What are you trying to do? Get to the other side. And the larger organization you get to, the more classic organizations, you see this lack of context and this pulling apart. And it might seem fine when you're in your silo because you're like, hey, I'm a application security engineer. Hey, I'm an operations engineer. Hey, I'm a QA engineer. Whatever it might be, I'm great at my craft. But if you look at the health of the end-to-end life cycle that you're a part of, the thing that you're getting paid to do, greatly the more difficult they are to deal with, right? And I already covered this point, right? So F's got all the ownership in the world. I can change everything, but I got no accountability for actually making it work when the customer cares about it. And the folks on the right have all the accountability, but they've got no ownership. I just take the crap people give me, and I have to find out a way to make it work, right? It's not a good way to run any business. If you took this to, Ford, that this is their manufacturing plant, they'd run you out of the building, right? It should be no different for technology organization, right? So what a lot you see going on, where all these DevOps ideas kind of push towards, is they all sort of end up in the same place, which is we're going to redraw organization or redraw to into more of these cross-functional teams with the idea of saying that I want to have a cross-functional organization towards things my customer cares about. So you look at the high performers, they say, look at your org chart, look at how work organizes in your company. Can your customers from the outside identify how that actually works, right? Nobody cares about, customers don't care about, oh, that's the AppSec team, that's the NetSec team, that's the InfoSec team, that's compliance, that's privacy, that's storage, that's, a development team A, development team B. It doesn't make sense to them. You look at the high performers, they say, let's assemble those people around what we're trying to achieve. That's the store warehouse team. So, they're fundamentally realigning their organization, these value streams, these customer identity value streams, and then thinking about how do we improve throughput and quality through those which is a very key part of this is the culture behind this. And if you're in a big enterprise, culture is a slippery, sticky word, and people don't like to use it. So use organizational dynamics, okay, or alignment and incentives, or whatever it is that works in your org. But you really need to to understand the culture of making this work. And a lot of that really comes down to this this notion of freedom and responsibility. We're giving freedom service to the customer, but we're also giving them total responsibility, meaning that they have to meet the full context. They have to meet all their compliance constraints. They have to meet all of our security constraints. They're getting their mandate from the outside, but then we're empowering them to going, right? So it's none of the, oh, I did it once. I got freedom. I did what I wanted to do, but then I don't have any responsibility because it's the ops team and the SIs. They'll catch. It's not today's talk. You really want to know a lot about that. There's a guy named Roy Rappaport. He's done applications from Netflix. You can Google cloud operations at Netflix or actionable metrics Netflix, and really dive into this freedom and responsibility idea and how that manifests itself. And it's quite fascinating. And by the way, at the end, bit.ly short slides or notes or whatever it might be. So all right, so how, right? So okay, great. So we got this idea that that everybody wants to redraw the organization. Cross-functional teams delivering services that the customer cares about and owning that thing from cradle to grave, right? So how do we actually do that? So this is actually this is a real value stream map. We had to squish it all into one page so it's a little bit kind of reinforces the spaghetti aspect. But large enterprise, they thought they had a deployment automation problem, right? Let me start with that. So how you read one of these things, or there's kind of a lot to dump on you here. These fat artifact flows, right? Things that actually, that's packages, things that are actually physical things that flow through the environment. All these little lines are information flow. It's conversations, tickets, spreadsheets, whatever it might be, right? To get through the organization to get your to get something done, right? And all these little pies here are how much time is spent in that step doing value producing time or waste, like wait time, wait for someone else to do something. So time on the keyboard versus total time for the step. And you can see the white is actual time doing something. The red is how much time something's just sitting with us, or we're kind of spinning our wheels. And they had a massive problem. It's taken 18 months to get through. So of course everybody was pushing things out as an emergency release, which just caused even more chaotic problems. But fundamentally they realized they didn't have a deployment automation problem. They had a problem, right? That everybody is another one. And so what they dependency management, also another. So what they did is, what a lot of folks realize, that kind of table stakes in this game is turning all that information flow as much as possible into artifact flow. So instead of handing off a document that tells me how to tell if something I installed is correct, hand off a test. Somebody can execute. So it's things come as packages. Instead of handing off another document on how to install something, it's actually giving me some executable code to do it. The idea of taking all the fact flow, very deep concept, a lot to go into here, so I don't have, but we can talk about that. So, once that happens, once you drive that information into that artifact, which is a major task. The other thing that teams are doing is they want to drive all-chain software development. Everything happens around Git, around our source repository. We got a CI server that builds our packages. Our packages go into some package, for deployment tools. It's going to take those packages and do something with it. So this is a nice, kind of pipeline. What's different about them, though, is that thing this way, right? So they're looking at the entire software stack from, from the operating system, or all the way, all of that is as much as possible is being driven as source through this SDLC. These packages, they're basically a version release, right? Now it's going to be different tools. It's going to be different types of packages. If you stand back far enough, you'll see a consistent life cycle across both application and infrastructure with strong relations. One of the good examples I think security really played into here is really teaming up with the QA folks and looking at all of the tests become artifacts as well. So they're focusing in on this notion of, but the speed people want to move, manual testing just doesn't cut it, right? It's an external inspection by a third to be manually testing something is not going to be enough to catch all of our problems. And if you don't believe me on that, we can talk about it later, but there's a lot that's been going on in the QA world to prove that reliance on manual inspection by third parties just doesn't cut it. In fact, most people take it as far as to say they don't trust manual, they trust if you do a repeated automated test. As a central point as well to start building an immune system, to say let's get the people that care about functional testing, the people that care about security testing, the people that care about performance testing in the source repository to drive the immune system for our business. Then all of that is going into some kind of repository, some type of operations console, right? Go ahead.
So is there some reason why you don't?
Yeah, because mostly, it's a loaded question. Documentation is information, right? If I have to give you documentation, now, do you mean documentation for like an end user?
You can deliver this to a customer, for example.
Right.
Whatever else.
Yeah.
You have to have someone
Right.
who receives the product.
Yeah, to me, yeah, that's just a functional requirement of the project, and that goes in the same life. It's got to be driven through the same life cycle. So really, in this kind of mind, so we're collaborating over here, and all this basically looks like a build process. So rather than being a software delivery life cycle, it's really a service delivery life cycle. It's like this is all the things that need to go into our product. So there's no difference. the artwork for your product and the functional interface of your product and the documentation. Might be different people writing it, might be different skill sets to actually write it, but at the end of the day, it's just a functional part of your product and all needs to be driven through the same process.
It's not test or code or configure or environment specification.
Sure, I mean, I ran out of boxes, but it would be part of the code. We call that content, right? So yeah. You got it, no problem. Yeah, I mean, but that's the basic idea, right? It's the same, and it's the same people that are doing the collaboration around the, the source repository, and they're executing the automation. By the way, the automation they're executing and the procedures they're executing was also specified and driven back to that source repository. So the idea being there that everything we do looks like a version product release. It's almost like product discipline to to operating online services. Were you gonna say something, Josh, or are you just stretching?
Yeah, well, you might have it later, but not the case where the people saying do static dynamic code analysis, look at the quality of open source components.
Yeah, where's that fit in?
Where do those
That comes later.
when they jump in?
Yeah, I'm going to get to that. So, but before we get there, there's another one too that says, okay, great. If I'm one company with one business line, I can do this cross-functional team. Fantastic, right? But what do I do if I have 30 business lines? If I have 500 applications? If I have, a global organization that I need to pull into this? I can't do that. I can't have, all my QA experts in everywhere. I can't have, my security experts. There's not enough of you guys to be everywhere. Monitoring, metrics, all these are kind of cross that need to. One of the most classic ones is environments. I can't have a separate network and a separate infrastructure for everybody in my organization. So how do these companies, when they're redrawing this organization for these cross-functional, customer value aligned teams, delivery teams, how do I deal with these cross-cutting concerns? And if you look at what they're fundamentally doing, they're basically saying, if you are a cross-cutting concern, you need to turn it into a service provider, service interface that can be used by the rest of the organization to pull those services as needed, right? So again, that it's not I'm not sending something over to them for them to do something with it and send it back to me. It's they need to turn their job around to where it says I'm providing a service that those folks will use. For example, QA. We see this happen a lot with QA. QA organizations are mysteriously disappearing. And the QA folks aren't going anywhere. Quality is actually getting better. So, what's happening? They're saying is that we're making our QA team be nothing but toolsmiths and coaches. They're there to teach the organization and about what the standards are for testing, how to do the testing. They're working on creating basically tool organization can consume to define their tests and to run their own tests, but they aren't actually doing the testing. The actual writing of the test and execution falling down to these cross-functional teams. So they're taking on themselves to say, we're a service provider now. I'm going to create a service that those teams can pull from. It also creates a very interesting dynamic because it makes you have to create a service good enough to where the rest of the organization will want to use you versus replace you with somebody else. Like we see happen a lot with environments, right? That it came down to, I'm tired and wait on operations to give me infrastructure. I'm going to go to something like Amazon. I'm going to go to a cloud service, and that's the key idea here is that it functions like that. To say, I don't really care about how Amazon does what it does. I have an API. The API says, give me X number of environments, and it's me. I'm on demand, and I can pull it. So, how do they do it? So in terms of being a service provider, what are the these organizations do? They think about offerings, right? To say, these are the 10 kinds of platforms that we support. You can get any of these on demand, as many as you want. They think about it as a pull-based relationship, that the users are pulling these services as they needed. And it could be a web UI that you hit that something shows up for you, like an environment. It could be you call. It could be a tool, like some types of these analysis tools that Josh was just referencing. They're on demand and self-service. It's not fill out a ticket and wait for somebody. Push a button and I get what I need when I need it. The implementation knowledge is there. They use the same concept. They have a source repository that they're working out of, but it's not necessary for normal use. Monitoring team is setting up the monitoring service that they're giving me to use. I just know, here's my APIs, here's my libraries I can use. I use those APIs and libraries, and oh look, here's the dashboards and operations once my code gets there, and I can see it all instrumented, and I can see what I need. And the interesting part from a professional development perspective is the providers, the people in these providing teams, cross-functional providing teams, they're spending their time building a service and coaching their users. They aren't spending their time in the mud actually doing the work day in and day out. They're thinking, how can I build the best service that can be pulled by these other teams to make their life better, accomplish our goals. So, it takes this kind of holistic mindset like talking before about, you got to think about it from an organizational perspective, process perspective, and a perspective. So kind of 4 quick steps to get started down this path. One is you got to define your offerings, right? This is purely a people and process thing. You got to say, what is it that we need to do to provide this better security service to our to these delivery teams for them to pull and use. And don't like, oh, we're going to give them Oracle as a service. Think of it how Amazon does. It's like, here's S3, here's your storage service, here's your database service, right? They're very functional. What you want to get, what you want to get done, and then build the interfaces from there. The second part is taming the tool sprawl, right? So you got this sprawl of these various scripts, various tools, things you do. If you look at how these high performers do it, they don't say, hey, our developers don't care about the 11 tools that I want them to use to scan for vulnerabilities. I need to tame that and bring that into one common service, one common interface that they can use, one common configuration they can use. Keep it simple, keep it easy. So that's purely a tooling issue. Once you've got the tool sprawl tamed, it's about setting up self-service interfaces, right? That's one of the most critical parts, is it can't just be these 5 scripts. That's not a self-service interface, right? And it's a two-way relationship. They need both the button to push and they need the feedback from which that button is pushed. Again, think about using your favorite SaaS service, not using your favorite set of tools. And then last one being set up secure access. Some companies, like Netflix has this thing where they say that even the secretary can deploy to production. Like literally nobody, once you're inside their network, you have free reign and free love to do except for the PCI. Really up to you. No enterprises work like that. They need to be very specific about where things happen. Rundeck plug here. If you really want to look at and say, what's an example of a tool people are using to do these bottom 3 things, once they've got their offerings defined, set up self-service interfaces, set up secure access. It's an open source project. You can go ahead and try it out, rundeck.org. Had to throw that in there. So what are the things that can't be automated, right? What about, hey, we need to do a security review, or we need to do some type of that coaching I was talking about, where folks want to come in and say, I need you to come look at this architecture, or sit in my design meetings, or whatever it might be. A good rule of thumb to think about is that in a systems are used for exceptions, not for the day-to-day work, right? Typically the indicator silo, right? I'm going to fill out something, pull it off, do something for me, get it back. It's going to be wrong, back and forth, right? It's a typical spiral of death. And if you see what the high organizations are doing and thinking about throughput and flow, they're saying, hey, how can we actually? Well, I guess sorry, let me back up here. These request queues, that leads to bottlenecks, slows lead times down, reinforces organizational silos. It leads to misinterpretation or omissions. That value stream map I showed you guys before, if you walk through and say, where are all the points that you have ticket systems, the more ticket systems you see, and there's the more throughput problems and quality problems they end up having. Interesting correlation. And you can usually jump into that place and say where you see handoffs through a ticket system, that's usually the hotspots. We track where things go wrong. So, the things you can automate and you can turn into a self-service request, that's great. But what if you can't, how do you mitigate the negative impacts of these if you can't automate it? Like design reviews, right? What do you do? And something simple, think about it as a work management system like Kanban. Kanban's great for this stuff. Are you guys familiar with Kanban? Okay, great. So I'll bring up the obvious points. The obvious points you already know. So let's talk about, if you set up a just like you were doing with your automated services, set up a well-defined set of offerings. So a design review, or we're going to do a coaching set, a 4-hour coaching session, or we're going to do a pen test, or whatever it might be. I guess the pen test would be, there's these standard human services that people would do, and we're using them to, through this kind of system to also enforce the work in progress for each part of the organization. so we can work on optimizing the flow and get to the point where we're starting to have a guaranteed service, which makes the organization extremely happy to say, hey, we've got these standard interfaces and we've got a standard SLA for you. If you want something outside of this, then you got to go and raise it about as an exception and try to negotiate that way. Maybe we need to add an extra service. And using something like this is really essential because the work in progress limits, you can also protect the capacity of your team, right? So that's one of the greatest side effects of seeing people going to this service required services is the complaints about I can never get those people to come help me, or I'm getting pulled in one of my guys and I can't get them to do anything else. All those problems tend to go away when you treat it like powered service and use some type of work management permission system like Kanban to rule it, to make it through. So all right, as the other big complaint here, oh my God, security compliance, like we can't do this. This is impossible. We need to have all these separations. We're just going to lose control of everything, right? So let's look at, there's a lot about this in various conference presentations where they dive deep into even how people do this type of thing in, PCI compliant environments. The guys at, $1 billion+ worth of online transactions, obviously serious PCI concerns, obviously, and they run this type of process, and they've got a lot of detail on how they do it. But let me just kind of point out the highlights to say, well, where are the leverage points for security, right? About having a single place. Now, metaphorically, I say single place. There might be multiple repositories. Might actually physically look. In a theoretical sense, we've got one common place where people are all changes being driven through, and we can interact with and make it part of views there. Through these automated build processes is where people are hooking in. We talked about earlier before about Gauntlet. So a lot of the in the lobby, I'll talk about this, but hooking those services into that build process. Really collaborating with the QA folks to look at the testing side of things to say, hey, build all the security tests we want into that. Obviously, component vulnerability. What the hell is environment? This policy and operational security checks. So really, there's far more opportunity for to actually leverage security here, and everything can be driven off of the tools, information from the tools, except for people working on the design and code reviews and writing additional tests. Compliance, same thing. What's changed? Where did the change go? What do we use to validate the change? Who has access to what environment? What, when, and where? What was executed on the box to make the change? All that information is readily available, and the human interaction is really, just those two points. So. One last thing here. If you want a litmus test for, hey, how do I know? I want to get involved here. I want to suggest things to the company to make it better. How do I know the things I'm suggesting are going to be working in the right direction here? It's sort of a DevOps litmus test, right? First one: am I helping folks to reduce cycle time and improve quality? Right? Am I helping handoffs to reduce the friction of the eliminated? Am I improving tool-to-tool artifact flow and eliminating manual? Am I eliminating those manually fulfilled request queues? And other sources of people waiting around for other people? And am I improving the awareness and understanding of the current state and desired state of the end-to-end system? Now, honestly, if you hit all 5 of these things, it's awesome. Usually it's any of these things, it's time to go back to the drawing board, because that's what your suggestions are going to be judged on by the because again, they're not just worried about quality. So that's it. I know I kind of blew through a lot of things, so the slide at the world's longest short URL up there, bit.ly DevOps at AppSecUSA. I'll leave it up there. 1 minute if anyone's got any questions, or I think people actually can leave if they need, but if you got any questions or think I'm smoking, let me know. Sure, thank you.
I was super pleased that you differentiated compliance from security.
Right.
Yeah,
well, I knew enough to know that. But yeah, and I think, but that is an issue that most organizations, one of the biggest complaints we see is that, both. Oh, sorry. So Josh was pleased that I separated compliance and security and knew to do the two things. But we see one of the, teaching to the test, right? That's one of the most common complaints we see is that people only care about it when there's an auditor coming, and then it's a 4-alarm fire, and we have to drop everything we do. So no one's happy with that type of relationship. The evidence collection side of things, as well as the immune system style, testing side of things, is a huge advancement that I think is, unfortunately, the silos between the AppSec, the InfoSec, the NetSec, the endpoint. I mean, it's a shame how much of a silo there is, because if they all banded together with the QA folks, they realize that they all have really the same goals. It's just what they write in their tests might be a little bit different. But it's really where that would be, that's an area of collaboration that I would love to see, more of.
If tickets are only for exception, how do you measure the performance of
Oh, right. Yeah, so the question is, if tickets are only for exceptions, how do you measure performance? So it doesn't mean we're not recording all that activity, but it means that the system is doing the recording, right? So some people make these tools, open up, basically dump the information into their ticket system, and they realize that that's terrible and they hate that. And instead they have their ticket system report to some other thing. The folks at, not to bring up Netflix again, but they have a thing called Chronos, which is a system that all tools dump information into, so they can know exactly what changed, kind of when and where. And so, you also would overlay the human activity, like tickets, over that as well, so you get a complete picture of what happened. So, yeah, we want to record everything. We want the log that the ticket system provides. I just don't want people using that as the interface for their day-to-day work. If that makes sense. That's when the silos form, and that's when bad things happen. But a lot of people do that because they know how to organize their work. And with more of a flow-driven system like Kanban versus a repository type system like a queue, like a database, they're measuring. They get better throughput, better visibility, better flow of work, and they still have an interface to protect them and to govern it. If that makes sense. Anybody else got any?
maybe one way to differentiate it is if the users can actually queue, right? That's different than I put in my ticket and then I wait to see if I get a response.
Right. There's that. And so that's nice about the Kanban thing is eventually you get to the point where you want to provide a predictable SLA. And which is not for like, I get penalized if I fail it. It's just to provide that confidence. And you see actually confidence go up. A slot can come available. I argue amongst my colleagues as to what goes in that slot. And then I know as soon as it hits that slot, I know it's going to be X amount of time before it comes out the other end, most of the time. And they feel comfortable and they see the work flow through and they see something stuck with the blocker on it. They go, hey, what's wrong? And you're like, oh, well, we got this going on in 2 weeks, this audit. Everybody stop working and go fix these problems. Then the other business folks just say, okay, we'll do that. But make sure everybody else, when I drop all these tickets down to a holding bin, I want you to make sure that everybody agrees with that, right? So it's just a great way to build that type of visibility and to build that to build those relationships. Makes sense. Cool. Anyway, slides are online. You got any questions? See me around or shoot me a tweet, your email. Thank you.
All right, we're going to get, this is our fourth, the 5-speech-long DevOps track. This is Chris Swan. I think I first met him through analyst practice at the 451. Really alpha male king in that he's incredibly technical and looking at the bleeding edge of technology adoption. Incredibly business technology for technology's sake, but in a way that drives business and profit and value and innovation. So really helped with a lot of some of those larger banks. And also just inherently conscientious about security. So he's really a triple threat. And as such, when I see people like the opportunities of something like DevOps, recognizing there's going to be gains and losses in security, listen to how he's embracing it the way they do, because they can form risks, not just be afraid of all new change. So more advanced and show you not where current DevOps people are taking it further and faster so that we're ready when we get on board. So thank you, Chris.
So I'm going to be talking a bit today about Docker. So stick your hand up if you know what Docker is. Keep your hand up if you're using it, and keep your hand up if you're using it in production. Okay, right. So why me? I made a decision a little over a year ago to fold Docker into the product that we make at Cohesive FT, where I'm CTO. And so I've been spending a lot of hands-on time with Docker. And yeah, it's a tool that I love, but it's also a tool where I have got to see some of the weaknesses in it, and that's partly what I'm going to be talking about today. And then customers to help them deliver solutions more quickly. I've been getting more and more involved in other people. I'm trying to take on sort of DevOps practices. But a bit about my impression of DevOps. So I think all good blog posts as well. So I won't leave it till the end for you to find out what I'm going to talk about. I'm going to talk about Docker and Dockerfile, and I'm going to show you how productive it is. And I think it becomes pretty obvious that when you've got something that helps you iterate as quickly as that tool does, then it's going to be great in a DevOps. How containers, which is the thing that Docker helps you manage, they don't yet. I'll take a detailed look at contain going and what might be done instead. I'm then going to look at images and what I'm calling the manifest problem. That is, you need to keep track of your stuff. So I'll explain in a bit more detail. So part one, what I mean when I say DevOps. Let's start with the demo. So this is sort of the install an Nginx server right now. run another container, and it's given me the next sequential port, so let's go take a look at that. So yesterday, who went along to Bruce's keynote? So about half of you. Okay, so Bruce talked about the OODA loop and John Boyd, and he was describing it as something emergent from the USAF, and I don't think it's fair to say that it's emergent. I mean, this is something that Boyd came up with in the Korean War. So Boyd was flying these things, Sabres, and he was getting his ass kicked along with all of his friends. MiGs was that the MiGs were faster in aerial combat. And he came up with OODA loop, observe, orient, decide, act, and kind of said the pilot that wins the dogfight is the one that can iterate through that loop of observe, orient, decide, act the fastest. And it turns out that in the dogfight, the one that can iterate the fastest is the one that has the most agile aircraft. So Boyd's also known as the father of the F-16, the aircraft on the top right there, because he helped design an aircraft that could turn the fastest, be the most. And the way they did that in practice was they made an aircraft that is aerodynamically unstable. So this thing would actually just pretty much fall out of the sky without a bunch of computers constantly changing the surfaces on the aircraft to make it fly straight. Now, what that means is that when you want to make it fly not straight and do a turn, it can break into that turn much more quickly than a design that's been designed. And so the F-16 is agile, and the F-16, for its time and even still now, is a great air supremacy fighter because it's got this ability to turn. So it lets the pilot go through his OODA loop much more effectively. Now, that we find this OODA loop, be with Schneier on this one, we find this OODA loop thing over the place in IT that help us as quickly as possible. So I just showed you a tool that lets us move fast. And so my contention here is Docker file, those kinds of tools, they're great because they let us be agile, and they're going to be adopted because they're great and they let us be agile. So taking a step back for a moment, I'll just give you a quick sort of my view on what DevOps is and what's happening. Related to this idea of industrial design maturity. And I'll kind of set the scene here using autos, as you call them here in America, which sort of replaced the manuals, which had legs. So we started out, in all industrial design maturity, we start out with design for purpose. So when Mr. Daimler made his horseless carriage, he was just interested in making something that worked. And you don't see the pictures of it with the gang of black around afterwards to make sure that it still does work, but you can bet that that was what was actually happening in real life. Because when he made this thing, there weren't factories that made engines. He just had blacksmiths. And you know, the art of making engines wasn't very well developed, so they'd have to keep on fixing it when it broke. Well, a few decades later, along comes Henry Ford, and he comes up with design for manufacture for cars. He makes a factory and a production line and Model T and all of the, any color you like as long as it's black. And then a few more decades and we get our Priuses and our BMWs. And these are cars that come not just as a product, but a bundle of services. So when I buy don't have a manifest of what went into my container. So I've now got all of them, and I don't know what's in them. And it's actually pretty hard for me to go back and forensically work that stuff out. So if we think about, we were running around our systems, automated or not, doing the OpenSSH or OpenSSL, seeing what version we got out, and then determining whether we needed to do something about that. I didn't show you entry point in my Docker file, but if I'd used entry point, that's telling the container management system can actually enter the container from a runtime perspective. So if I'm using entry point and I've pointed entry point at, let's say, node.js, and then my command parameters to that, I can't just get a bash onto that container. So I won't be able to go back to that container and run the commands that tell me which version of OpenSSL I put inside of it. So this starts to become problematic. What makes it problematic? So we all know what happened with VMs. VMs caused us to have VM sprawl. Well, my definition of disruptive when I used to do corporate finance was moving the decimal. And I'm expecting containers to expect them to move the decimal. So I expect us to be working with 10 times as many containers, at least, as we worked with VMs. So if you thought VM sprawl was bad, and you thought it was a pain to go and find out which version of OpenSSL you had in all of your VMs, in 5 years' time when we're doing that same thing with containers, oh boy, are we going to have a problem then. Unless things change. So again, Solomon's promising to fix things. This was Solomon chiming in on with a couple of guys from the OSGI community. Anybody in the room heard? Two of you. I thought that was going to be enough. So OSGI, for everybody else, is a system that came up along predominantly around Java for dealing with dependency mapping. So OSGI gives you a framework for handling dependency. And this whole manifest problem is related to dependency and version management. So we were chewing the fat on this, and Solomon kind of weighed in and says content addressable layers and end-to-end signatures along with hermetic bills. Sounds good. I'm really looking forward to seeing the details on that. Meanwhile, I think there is another way. The way that things are in Docker at the moment, we're using the existing Linux operating system repos in pretty much the way that we're used to. So we go along to our CentOS and our Red Hat and we go yum, 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 and we go apt-get install this, that, and the other. And so these kind of bloated containers that are full of an entire Linux package manager just in order to install the thing that we actually want and its dependencies. And then the problem is once we've done all that, we've got no idea what we put in because it's just a snapshot in a point of time. So the thing is we can say, all right, let's actually be declarative and deterministic about this. And one of the ways that we might be able to do that is something like Nix. So who is one? Okay. So not quite a null set on that one either. So Nix is a functional package manager for Linux and other Unix-style operating systems. And so a functional package manager is one where you've got a declarative approach to control. So you're defining a very specific dependency tree. John, you want to chip in here? The question's about CoreOS. Am I going to talk about that? So CoreOS is a new Linux distro that's come along as a place for containers. And there's a one from Red Hat as well called Project Atomic. So here you've got kind of new Docker generation distros, and neither of those things addresses this problem in the slightest, because CoreOS and Project Atomic are designed to run Docker. not designed to run in Docker. Yes. So well, CoreOS came after Docker. Though, so it'll always be perceived as coming late. Yeah, I see. So yeah, CoreOS doesn't help with this because CoreOS is the OS for running the host, not for the containers. So if you're using Ubuntu, Debian, RHEL, because RHEL's not in the repo, secret doors that Red Hat has for its paying customers to get that. And these package managers are creating this non-deterministic flow. CoreOS doesn't help here because CoreOS hasn't been designed to help here. Something like Nix might do. So a Nix closure is a set of dependencies to run a particular application. And there's a from Zeph Hemmel called Nix Docker, and that's been designed to basically take a Nix
Oh, we always do that. Much better.
It wasn't, he had to have the VGA on before.
I will turn this off.
operations. Chris Swan just took us through a much more advanced, this is how things are trending and how the scale and size problem. And now we all work with you. What is actually being applied by someone who cares about security, cares about operations, and is currently doing it at Rackspace. So I saw Matt's presentation in the UK on how he's doing it, and he's already advanced a ton since then. So tales of a DevOps, rugged DevOps practitioner. Thanks.
Yep, thank you. I'm going to live up to the title and come to the ground. Because I walk around when I present and I can't be behind a podium. So just let me know sound if my sound is bad. Quiet. But I'm going to move around and talk. So let's get started. Ground truths of a rugged DevOps practitioner. So who am I? I'm Matt Tesaro. I've been at Rackspace since 2011. Myself and another person started the product security group, which is now called the Security Engineering Group, and probably next week will be an unpronounceable symbol. And I work with the QE and developers. We're actually in the product development group. Do I need to consistent or better? Okay, we should be consistent and better, even if I'm never this formal, but that's okay. I can live with it. So that's the work side of me. The other side of me is I am very actively involved in OWASP. I was a former OWASP Board Foundation member. I've got a couple projects that I lead with OWASP, and I love AppSec. We good or be bad? Like, here, let's let a professional do this. Is that better? Ah, okay, yay. So now you can consistently hear me. Let's move on. So let's get into it. So I'm going to do like the 3-second overview of after, 4 other things of DevOps. I'm not going to explain this, but you guys get the idea, right? It's the whole stop the wall between ops and devs. Everybody gets together. It's all fun, cultural, people, process. We got all that. I'm skipping this slide, but I've done this in isolation before. And then just if I throw these acronyms, CI, continuous integration, CD can be continuous deployment or delivery, depending on who's talking about it. TDD, test-driven development, for those who may or may not have heard of it. And API, application program interface. Right, done. Level set. Let's move on. So the problem, and this was alluded to in several of the talks today already in this room, right? Cycle time for software is getting ridiculously short. And my crazy example I like to throw out is one of our teams at Rackspace last year, their average deploy to production in a week was 75. So like by week of scanning, that is the traditional I'm a security dude, is non-existent, right? It's my 3 minutes of scanning or something crazy. Particularly, windows are gone. Like that whole model is thrown out the door, right? And hard to your traditional security mantra, like you're going to fight the business because the first mover advantage is going to kill you every time because you will be seen as an impediment and you will be worked around, right? So this is like the old school way of thinking about security, it just doesn't work. And I had a little bit of this Rackspace, but Rackspace really drove this home for me. Like any of my old sort of thinking of, well, I need the week to do the test was like, done. Like, no, we gotta find another way. And then at Rackspace, we have tons of DevOps, agile, continuous delivery, which is even making it worse, and even more at Raction, particularly in the static analysis world, is also out the door, right? So it's just like, even when you think you might have a chance, you get that low body blow. And then even better for group, we have tons of RESTful APIs that don't bother even with a, what is it? Oh, a waddle. We don't even do the waddles, the API. So we can't even programmatically interface with them, right? And there's no good tools that I know of that really do fully automated REST testing. There's an okay job to doing it manually, right? Somehow. So this is once again another artifact of the fact that like traditional you automate like crazy. And that's what we've done in the product security group. Oh, well, I'm going to say that all day long. Security engineering, whatever we call us. Automated software testing, automated operational infrastructure testing, and automate security testing. So let's talk through those. The other thing, like, my first job out of college was a developer for a international telecom who, oddly enough, their data center was down in Texas. Really hard to understand because almost all of our operations were in Europe. But so a lot of the security people I run into don't actually, I'm fortunate. I started out as a developer. It's easy for me to think like a developer, but you really have to think like a developer, and figure out what tests you can chop off and run sort of a la carte. And mix, like a normal infrastructure test is really a whole ton of little tests all jammed in together. Well, which ones of those can I automate and break out and separate and maybe do as a interval as opposed to on a scan window? And then you kind of have to be, well, you kind of have to be a little bit smarter. When I was a consultant and doing just traditional pen testing, as long as I got the engagement done and the time window that the engagement was in, we're good. So if I had to like sort of knock up some quick and ugly Python to do something, if it wasn't particularly optimized, it didn't really matter. It just had to get done before the engagement window was done. But if now we're doing these things on a repeated cycle, you actually have to write decent, reliable code, right? It needs to sort of be optimized. You can't assume that you're going to get a long run window. And then try to think about the idea between like a smoke test and a regression test, right? And I like to think of a smoke test, the test early and often, is like you must be this high to ride the ride, right? Like I want to get as much of that automated as possible. No, it is not perfect security testing, but it's a lot better than getting no testing done because you want to be a purist, right? So we've found a lot of things at RAC where we can sort of determine you're at least this high and you're cool to ride the ride. And then maximize what you got. Like this is another like funny thing that you can get tons of traction for very little cost. The perfect example, we have a lot of Django apps knocking around. Well, Django apps is a Boolean true false for CSRF protection, and it can something you can write against GitHub if they check in a Django app. I mean, that's greppable, right? In that file, is this turned on? No, fail. Like that's a 3-second thing. I mean, static analysis by grep isn't cool, but it really works in some of these cases. So if you understand your frameworks and what security or options are there to begin with, you can actually get tons of traction really quick. And this is something that you can make a check and hook, right? The minute I check in my first Django thing, you can fail it. It goes red. And then you have to make the tests repeatable and easy to understand, because quite honestly, I've been fortunate the last chunk of time I've been on one project, but usually we're bouncing between products. There's way more products than there are security people at RAC. So I may be testing cloud servers one week and cloud databases the next. And if it comes up, it's another person on my team. He's got to be able to run my tests without a lot of interaction on me, or else we're all slowed down. And then this is where the Unix philosophy of doing small, simple things that do one thing well, you really have to make your security tools do that, because then you can really start this a la carte mix and match, right? Simple little tools that test one aspect of security. Then you can start deciding how many of those I can combine within my window. Because like I said, Rackspace, we have a lot slower. There's a spectrum of what I see. And so maybe for some groups, I can do all, let's say 50 checks, our automated checks. As their timeline is a 2-window sprint, I get some breathing room. For those faster groups, maybe I can only pick the top 5 that are really risky for this particular type of app, and I run those. So if you don't have these things mix and match and combinable, you're sort of doomed to begin with. Right? So these are just good fundamental principles when you're doing this testing. And I need a drink. Test-driven security. So I like the idea of test-driven development. And the tests, and you're failing, you write code until the tests pass. This is the same idea, but with security. Development, right? Your code works when your test passes, and you write your test first. In my mind, test-driven security, which is kind of DevOps security as well, you know your app has made or met a security baseline when it passed the tests. And security baseline is really key. I mean, I've had arguments with fellows in, oh my God, you're not testing all 833 variations of everything. Well, you know, that's cute. I don't have time for that. And there's 100 things that I really, really care about. And maybe once it's out on production, I'll check those other things. But you know what? The other nice thing about that really fast cycle time, if I find a problem, it gets fixed fast too, right? So I bet you money in a lot of cases, if you have a fast cycle time, even though it is exposed in production, that window is shorter than if you don't have a fast cycle time, right? So there's actually the wonderful case, that same really fast team. One of my other coworkers was testing it. Window open with that team, he's testing them. They're out in California, we're out of San Antonio. He's testing, he finds an issue. Jumps in the IRC channel, hey guys, I noticed I can do this and I shouldn't. Oh, what does that look like? Oh, here's what I did, here's the curl, whatever. Okay, cool, let me look. Goes back to testing. Gets a ping on the IRC, hey, it's fixed. Like what? He didn't even have time to write up the finding before it was fixed. So yeah, the speed stuff is crazy, but it can also work for you, right? It was kind of like, so we ended up having to write a finding and close it. Like boom, boom. So it's time to mourn. Like traditional application security is dead. Like if you were doing it, you just might as well plant it and move on. And we did hardly know you. It's such a nascent industry. So I'm going to talk about the 5 stages of grief. What, back one? I can back one. Yeah. No problem. Yeah, I love those generator things, man. You can have all sorts of fun with those. So let's talk about the 5 stages of grief, and you can find out where you are in the spectrum, right? Denial, right? That agile thing is a fad. This DevOps thing is a fad. It's never going to catch on. It's just crazy. Waterfall is the only way to produce quality software, right? And there's still some people out in the world that firmly believe this. God help them. Right? And then anger, like there's no way I can test that in time. Like if I see another freaking sticky note on the wall, I'm gonna go loony and like just run down the halls and be crazy, right? Or maybe bargaining, right? Well, I think I can test some of it in 2 days, but I really need 5, but so you won't get a full test, you know, and we can do it after it's deployed to prod, I guess, and we'll give you an exception, and all this bargaining happens, right? And then depression, like after that launch, I updated my LinkedIn profile, like I'm done. Right, and then aliens, right? Game over, dude, game over, right? And then acceptance. This is where you want to be, right? So when can you to work on that regression, right? Hey, I need this to be in the next sprint. Pull out of that sprint and add in this thing. It's actually a high priority issue, right? Your deployment recipe, a pull request, change your salt stack, or I forget what Salt calls their things, your Ansible playbook, to harden that server a little bit, right? These are the conversations you want to have, right? So I'm going to talk about these 3 areas to get you from denial into acceptance. And these are things where I broke my knuckles at RAC and other people on our knuckles at RAC, but we've actually gotten a lot of good traction. So let's talk about securing the infrastructure. And we kind of break stuff down into infrastructure as in code. That's just kind of works well for RAC. I think generally this would work for anybody. It kind of depends on what your environment is. But for us, those are kind of the 3 big key areas. So infrastructure, right? Hopefully you've got Puppet, Salt, Ansible, Chef, something deploys in your infrastructure, right? These are all over RAC. Unfortunately, I see Puppet, Chef, Ansible, Salt. At RAC, I see them all. I haven't seen CF Engine, but there's probably some somewhere I haven't found yet. But we've got them all. But these are great things. And as a former sysadmin, one of my hats was a sysadmin. I wish this had existed when I was managing servers, because this is really cool. Like I know that when I launch that server, it looks like the last one. That's awesome. Everybody knows Chef, Puppet, Salt, Ansible. Do we know those? We understand what they mean, right? You have an idea of, you have some sort of sysadmin, something, it gets pushed out to nodes, they get configured accordingly, right? And there's different modes, and this is Chef, but whatever, right? And you have cookbooks, stacks, playbooks, whatever you call them, right? And it's some sort of way to say, this is what I want the end result to look like, and however your particular technology wants to do it. But the thing here from a security point of view is 1, you know, all of those things are the same, right? 2, like if I read through this and I understand how it gets deployed and I can suggest fixes, those fixes happen to every future deployment, right? Anytime you launch a new API node, if I've made a change or a PR and fixed it, all new API nodes will have that change. So this is a huge place that you can put a little bit of time and get giant win. Like one of the product teams was using Salt. They spun up a couple instances of each of the different types of servers they had. We did a VA pen test against them. We found a few things. We fed them back to the team. They updated their Salt stacks, redeployed, done, right? This is like a great, great way to get tons of traction. And if you want to be really nice, like some of these things you pull off the public repos are scary, bad. If you want to get some karma points, push them patches upstream, right? And get a hardened Apache, not just like, hey, port 80 works. And then the other thing you can do with most of these technologies is do some sort of tagging, grouping, sorting, right, of these types of servers, right? You can have different roles or what have you. And the tagging is usually done to apply like what's required to happen to that server, right? A web server should have Nginx installed in it. A database server should have Postgres installed in it. A monitoring server will have whatever installed in it, right? Well, take those tags or roles or what have you and apply a security policy to them, right? Because the Puppet Chef Ansible Salt has already told you what its role is, right? And you have an understanding of the risk of that system in the app it is. You can apply policy based on those tags. If you're really smart, you can read those tags out of the repo and actually talk to the servers in the same way, right? Like, you know, I can get a list of all the database servers and I can check them for database things because in the repo that has the Ansible playbook, well, the Ansible config, it's all listed out, right? And then an inspector. This is a really cool idea, and we've done some of this. I haven't done it as much as we'd like. So for each group or tag or category, role, what have you, review the recipe and hook the post provisioning so that you run your own bit of check. And the idea is, like, think about when you build a house, right? You have an architect who designs the plans, and you have a builder who builds the house. What do you have, hopefully? An inspector that comes in and makes sure everything's to code. This is the type of thing you want to write, right? Because now, when you do this, every time it's built, you have a way to go back and check. Hey, I just popped a new WordPress. Let me go in and make sure it looks like it should, either from the inside or outside, right? As an external scan or maybe an internal look. I did this with our container team. I've been working with there's a container team building an internal use LXC container product at Rack. I actually wrote a bit of shell script because it's a very minimal OS we launch. So I wrote a whole bunch of SH that would go in and check 126 odd things that we cared about, like, is this on, is this turned off, etc. And I wrote a bit of Python to automate that in Jenkins so that for every check-in of the container service code, I pop a new container, I drop my SH in there, I run it, I pull a report, I blow away the container. And we've actually found regressions based on me. And this is, the developers, just as another Jenkins job. And like, oh crap, it's red, let's go look. Right? So I'm a guy, but I think to the containers team, I'm just like another team member, which is a pretty cool place to be. And agent. Yes, another important thing. So particularly at Rackspace, we're a cloud company. We have lots of cloud servers, right? Things come up, things come down. Environments go up, environments go down. And when you don't have long-running servers, like we're having something, this doesn't work. So drop an agent as part of that standard deploy. And then that thing can, in essence, be your narc, right? If the server gets out of compliance, or whatever policy you care to apply to it, right? If you are doing this, writing an agent that's read-only will help you sell it to sysadmins, right? Because if you have an agent that can fiddle with stuff, that's really not well taken by system administrators, so read-only is a huge plus. And then you just look at the state of the system and report back to the mothership, right? You can take that and make a dashboard out of it. I remember when this is probably 2 years ago, when the Jenkins vulnerability happened, that we have this in place, and we did the mad scramble to find all the Jenkinses, and then patch them and check them, and how cool would it have been to have agents on all those things, turn them all red, because we update the policy that Jenkins must be greater than X. Board goes red, you find out what team has them, you make some, a few emails or conversations, and you watch the board go green, right? This is the kind of really cool stuff you can do with somebody on the box who's sort of letting you know the state of that machine as it's running. Yes. There's a couple different things you can, like Cloud Passage is a commercial company that's actually pretty slick. Mozilla wrote this thing called MIG Investigator. It's actually the hashes of binaries on the system, but I've thought about co-opting that because it's pretty nice. And there's another tool called Linus that does a whole bunch of security checks you can run inside of a Linux install. Oh, and then turning vuln scanning on its head. This is another thing, right? We do tons of threat modeling. And I kind of cheat when I do threat modeling because I have a bunch of people in the room that know what the heck is going on with the system. I not only do the traditional data flow diagram thing, I find out what technology they're using, what underlying OS, et cetera, get all the metadata about that application we're threat modeling. We take that, dump it into a DB, and I've done this at previous employers as well, you subscribe and parse the, the announce lists or the security lists, right? And if you want to do this for super cheap free, Gmail plus filters will get you there, right? Or there's commercial things like SecUSA Vim that you can pay for, and they'll do the managing of who and what for you. They have like 40K products. But the idea here is now the conversation is, oh, by the way, that product's been out in production for X period, X months. We finally got it scanned. Oh God, all this stuff is really out of date and has been for months. We have to mad panic and get it patched, right? Now it's like, hey, guess what, guys? There's a Tomcat vulnerability that just got announced. We got to get this in the next sprint or two. How are we going to get that done, right? It's a totally different conversation with your ops team, right? Now it's not a, oh God, mad panic, run around, international sign of panic. It's a like calm conversation about how can we roll this out in a sensible way so that no one has to like spend a weekend of heartburn, but we still get the thing patched. And I love the fact that that reverses the mug, because like when you proactively go to a team and say, hey, by the way, something just came out today, right? I know we get this fixed over the course of your, like we're gonna have to inject it in your normal work and there'll be some interruption, but it won't be a, oh God, weekend stay up all night thing. That's a huge win when you those jokers to stay there over the weekend. Okay, that's infrastructure. Securing apps and APIs. Oh yes, oh yes. So PDFs are great, bugs are better. And when there was an allusion to this earlier in the same track, did consulting for a while as a pen tester, and I wrote lots of formal reports. If you've ever talked to anybody who did pen testing, they bloody well hate writing reports. And I don't blame them, because most of them don't even get read. What we've done at RAC, and I've done at other places, is I don't write reports anymore. I submit bugs and like reports. Because I take that back. Occasionally management wants a report for political reasons, and then you gen one, but otherwise there are no reports. It's awesome, right? What are the developers used to working with? Bug reports, right? This is cool. I would highly recommend creating, if it doesn't exist, a security category so you can distinguish yours from general functional bugs, right, when you're pulling reports. And bonus points if your bug tracker has an API, because then now you can automate this, right? Done with test, push to bug tracker, right? Because you don't want to be copy pasting. That's not cool. Although it is part of the traditional workflow now, the one thing you have to watch out for is death by backlog. Right? You get the project manager saying, oh yeah, we put that in our backlog, we're going to get to it, and it just dies there, right? So this isn't perfect. A lot of times I've had good luck with teams sort of talking them into an occasional security sprint. Like you have a lot of medium, low vulns, none of them are super scary, but let's maybe 2 sprints from now doing a security sprint. Let's just kill all these little silly, low, medium issues that are sitting in your backlog. That's been pretty good. And the other thing is you have to learn how teams treat issues, because you have to talk in their language, and unfortunately some of ours are backlogged, some of them are issues, some of them are, they're all over the place depending on the team, so you just have to sort of learn and adapt, unfortunately. Oh, and for metrics and pumping issues into issues tracker, ThreadFix is very good. Dan Cornell did a talk earlier on it. We use it at RAC, it's quite a nice thing. I would highly recommend it. And it's just getting better all the time. We actually developed the version 1 integration for that, because it wasn't there and we have that, so. And then for the reticent, yes, nag. So what we did at Rackspace is for every one of our security levels, there's 5 different levels, we attached an SLA. And an SLA isn't getting it fixed, it's getting a remediation plan in place. So for our most scary issue, it's 24 hours to have a remediation plan in place. And that plan may be, oh God, we have to completely re-architect this thing and it's going to take 6 months. Or it may be, yeah, we push this patch next week and it's fixed. But it's a plan, right? Because unfortunately, if you try to do SLAs for getting it fixed, like you never know the scope of getting it fixed. That's really hard. But generally speaking, management is cool if you know it's a known issue, they're working on it, it's in this sprint, it'll be done at this period of time, we can go back and check with them, right? Then you're good. And then what we do is we age all of the bugs that we have in ThreadFix against those SLAs. We start off with polite warnings of like, hey, your 3-week SLA is getting kind of close, right? Start maybe with the project manager, depending how your org structure is. Start with the project manager, and as it gets closer, maybe you start walking up the org chart. Okay, head of development, by the way, these 3 teams have these long-running issues that are past their SLA. Might want to have a conversation, right? It'd be nice if you have a dashboard. We actually kind of use ThreadFix to be our dashboard. And I would definitely recommend getting management buy-in first, so you don't get political backfire when you start walking up the org chart, right? You definitely want the manager to say, hey, I agree to these SLAs, management. I agree to the SLAs, and I agree to them sort of be gently nudged, if you want to be political, into compliance, right? When you do this, it's been fantastically useful. Reports equals findings plus automation. This is another huge thing where we've had a silly increase in throughput. So we happen to choose ASCII doc. I don't really care. Pick a markup that you like, plain text, because most of your security people are very fine opening up Sublime or VI or whatever and knocking out plain text. They don't like particularly opening up, I sure don't like opening up Word and making fancy documents and worrying about formatting. That drives me nuts. So pick a markup that you like. Pick a standard way you want to write your findings. Use something like pandoc, which will convert almost any markup into almost any output. And now you have a way to generate reports very quickly. Oh, and by the way, now you have report as code almost, right? Check in your reports into a private GitHub repository, and you can actually do diffs on reports. Like, isn't that kind of cool? That's kind of cool. Like, I have one report I have to send a PDF on a regular basis, but another one, they want an email. Same content, you generate one as a PDF, you generate one as HTML, you copy and paste it into an email, you're done. This was huge for us. The cool thing too is, right, the testers are writing the least amount possible. And we actually wrote a little Django app to take these, the Django app that, let's say that we've never done any testing before. We find a cross-site scripting. You write the title, you write the description. Cross-site scripting is blah, 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 right? That's in every finding block. But you don't need to write that but one time. So our Django app, the first time you have a new type of template, or type of vulnerability, it saves it as a template and you can reuse it next time. And only things like impacted systems and the risk changes based on the context of the finding. Now you're only what systems are impacted and maybe a little bit of changing of the risk based on context, but that's it. Right, so we've gotten crazy higher throughput doing this. We started out using Dratus. Unfortunately, Dratus doesn't enforce, say, correct syntax of markup. So you'd pull stuff out of the Dratus database and try to gen it, and it would blow up the markup engine. So we've now abstracted all that into a database. And then we can just gen the markup instantly, which is really cool. Because the other thing you can do is if you have one finding that's particularly problematic, and you want to get it to the team fast, you type it up in the form in our Django app. You say, show me this in ASCII doc, you copy paste it, done. You have a finding instantly just for that one block, right? Or you take all of the findings for an engagement, and you have a report. Or you take those findings and you jump them directly into a bug tracking system, right? Because I've abstracted all the bits of a normal report into atomic pieces, and now I can shift and move them around as I need. And this gave us huge throughput bonus. Leverage existing consistency. So if you can find, consistent, particularly computer-generated output, use that, right? Find those, write some scripting, and I'll give you examples. This is a way to automate the drudgery and get rid of the silly paper cuts that make you hate your life. We automated finding and bug submission. I've kind of talked about that already, right? You need that you shouldn't ever have to be typing something into a bug tracking system ever, right? Or you're doing something wrong. Automate PDF report generation. I talked about that with our bug tracker and using ASCII doc markup, right? If I need to make a formal report, it's a database query and a call to pandoc, and I'm done. API documentation to basic test harness. This was my coworkers Michael did. So OpenStack does not produce waddles, so there's no programmatic way to understand the methods exposed by a REST API from OpenStack, which is annoying when you actually want to test it, because testing it, you usually have to write a little bit of stub methods to make all the method calls to understand what's there, and then you can start playing funny with them, right, after you can actually talk to it legitimately. So Michael wrote a tool that would go out and, I should back up. The OpenStack documentations are programmatically generated, right? The docs.openstack.org are programmatically generated, sadly enough, based on waddles. I got 15 minutes, okay, cool. I will move faster. Anyway, he wrote a bit of Python that reads that HTML of the docs page, creates stub code for all of the method calls, and done. Now, yes, it's not functional code, but it gives you all of this, scaffolding you need to get that done really quick. That was a fantastic idea. Another really cool one for reflective cross-site scripting, we handed the developers a static web page with links. Done, right? Click on these things. If you don't see an alert box, you fixed it. If you do see an alert box, keep. And when you get no more alert boxes, talk to us and we'll check it again, right? Like it stops at like, I fixed it, no you didn't, I fixed it, no I didn't, which is evil. Oh, and then I've written a couple tools to take and combine different security tool output into our standard format, right? So if I run Nessus and Burp and something AppScan or something, I can take all of those, jam them into our normal workflow, and done. Okay, securing code. So, start with the developers. Like the findings that you write, this is my mantra to my people, have to be detailed enough so that in 6 months from now I can reproduce this finding, right? I don't want like, I did something and badness happened, right? That's not useful. It has to allow QE or security to be able to test and fix that issue and not you be the QE or security person testing it. And then give enough information for developers to actually fix this thing, right? Like a link of a CS or a reflective cross-site scripting is not particularly useful, right? Here's where you can do like we send a lot of quick and dirty scripts that exercise that vulnerability to the devs. So I found a way to take out one of our APIs with a particularly crazy call. I wrote a little bit of Ruby. It was like 20 lines of Ruby. Here you go. Run this thing. It'll take your API offline, right? Do it in staging. But as you think you have a fix, run this again, right? And when the thing doesn't die, when this thing runs, then we're probably good. And come back and talk to me and we'll retest. Like those, oh, here's the reflective cross-site scripting one. I jumped the gun on that one. And then Gauntlet is another great tool for this, which has been mentioned here a couple times already today. An interesting thing for us, once we really had this going fast, we had interesting training requests like, hey, our group is getting hit by these things a lot. Can you give us some training so we don't even talk to you? I'm like, hey, yeah, we'll do that. Be happy to. Okay, and then cherry strained as a security team anywhere. I don't care where you are, right? We do, like I said, tons of threat modeling, and we use that to sort of guide the testing efforts and the areas that happen with whatever app we're looking at. So focus on weak or weird or suspicious areas. If there's any sort of threat boundary jumping, if there's any kind of transition from XML to JSON or format changes, right, look at those areas, and that's where you focus your time, right? Because you won't have enough time to do a holistic one, more than likely. So find the scariest bits based on your threat model and really focus on those. Maybe you get lucky and they don't take as long. You can look at it a couple other pieces, but probably not. And then if you have code changes in those areas, OpenStack, by the way, has this idea of like a +2. So if I want to submit a code change to OpenStack, I have to have 2 developers +1 it, and I get a +2 and it goes. Maybe for those scary areas, it's +3, right? Okay, I know these parts are particularly sensitive. Like they're the ones that manage the keys for this app. Those need a +3, and you can hook that all up in Garrett, right? These have to have a 3+ votes before they get integrated, right? That's another great way to sort of help them get a little more rigor. There's search feature, GitHub instance. That search feature is ridiculous. Sort of gathering a list of problematic calls or things that are greppable, and then just start grepping for them. And probably the best thing about this approach is it's organic, right? You find one problematic call, fine, you grep for one thing. You find 2, now it's 2. And in 6 months, it's 87 things, right? Like the systems that can be built are really the systems you want to build, because you're never going to have time to build it fully, but you can always add a little bit over time. Even if you can automate code review, you have to triage it, because I think there's any like math, but I would bet you that one false positive in terms of cred points is worth about 100 valid bugs to a developer, right? I mean, the minute you give them BS, they will call BS or an idiot, right? So you really, really have to make sure that that is an actionable item that you're handing over as right? Stick to diffs. I've already sort of talked about this, right? Threat analysis, scary bits, code diffs. Those are the things you look at code or the sensitive app. I look at the code diff of a pull request, and it changes the CSS color. Done. I'm not looking at you anymore. Easy to do if you do it as opposed to a release level. And you just need to build cred points with the dev teams. And you certainly won't have that if you're giving them false positives or got a report and you handed it to them. Because I could probably train a monkey to do that, right? That's not really cool. And where's your value add? My value add is what? I like that's value add is the only stuff I give you is real, and you actually have to do something about it because it's an actual vulnerability. It is better than, yeah, definitely. So hire or befriend developers. We tend to hire developers that have a security interest, not security people that have a development interest, because it's easier to speak the language. You know, if you can go in and say, hey, I need to do a PR on this change because the last time you did a deploy, you know, if you're talking shop with the dev guy, ooh, bad, I need help. Here's a big 500-page PDF, you're done. And another key thing that took, quite honestly, in my years of security work, is you suggest requirements, not implementation details. And although this wasn't me, this person's action was the one that made me think this. One of our compliance guys told another team, one of the product teams, you must install Tripwire because of PCI. And this guy came to me because I had an existing relationship with this product team. He said, I want to do OSSec. What is this crap about Tripwire? Does PCI say Tripwire? And I'm like, no, it says host-based intrusion detection. OSSec meets that. If you like that, that's a requirement, you're done, right? So don't make a technical recommendation, it's a requirement. You must have something that does X, right? Not you must install this piece of software that I happen to like. Unless there's a corporate mandate, I guess, but not much of that at RAC. And then mitigation suggestions need to be generic or in the language that that app is in. Because if you send a Java code example to a Python guy, he'll laugh at you. This dumb idiot doesn't even know I wrote this in Python. He sent me Java. What a bozo, right? Like, make it generic if you don't know. And I've already mentioned this before. Fast deploys mean fast fixes. So yes, maybe if you are having a continuous deploy that happens rapidly, yeah, that's kind of scary. But that also means that when you find a fix and you get it in the pipeline, it goes out the door much quicker, right? So this isn't all gloom and doom and drink poison and die. There's actually some good parts to this, right? Okay, so what's Rackspace Security Engineering doing? That was me postulating. Now, what are we actually doing? So, I already said this. Rack has Chef, Puppet, Ansible, Salt, and whatever the next coolness is, we'll have that too. We have Docker. We have everything. Whatever .io thing, we'll have it. But for those kind of configuration automation scripts, we review those deployment scripts ahead of time. We actually do an audit of those deployment scripts for the teams. We validate them with external vuln scans, and we recheck after bug fixes. We actually had one team that was agile enough and was launching on public cloud that when we wanted to test, they actually threw up a shadow production instance. It really wasn't a production instance, but it was their production code done, right? Because they could just automate it. They were like, ooh, production at here. Whoop. They gave us an IP range, we're done, right? And if we knock it down, who cares? Because it's not real production, it's just sort of production. We use mole on a lot of our systems. We also have some mole-like agents we've used before. 10 minutes, I got it, thank you. And then Rack has been threat models with this additional metadata collection for a long time now. We have 68 of them or something. One of my coworkers actually had a really cool way to interlink them so you could actually kind of click through the various bits of our cloud. So our cloud server system talks to our identity system. You click on the identity system box in the threat model and it takes you to the identity system. Oh, the identity system talks to cloud files. You click on that. You're now in the cloud files threat model, and you could actually sort of do the bouncing ball through our entire cloud infrastructure. Link threat models, which is really cool. And teams like our BCP people went nuts. Like, holy crap, all this stuff is interconnected. Yes, it is, and here's a diagram. Have fun, right? They loved it. Securing apps and APIs. Our workflow, right? Somebody on the team finds an issue, document in our thread fix pushes them into a bug tracker, and then we have metrics driven off the thread fix database. The manual bit, but after that, it's just done. Cron jobs in essence, right? We had some breakage with the nag script we're actually re-implementing as we speak. One of the guys is working on that. And pick a markup language that you like. I'm particularly fond of ASCII doc, but it really doesn't. Pick a markup language that you can gen into whatever you need for output. Because you will be much happier writing plain text in the editor of your choice rather than having to do Microsoft Word in a VM because you use if you're like me. And then we use Veracode if the language itself teams wrote and contributed the original Jenkins plugin that now Veracode has taken over. And then we use API automation to pull findings into our workflow. So instead of SE person, security engineering person finds one and puts it into bug tracker, it's call the API and we shove it into the bug tracker. Or well, and then into the bug tracker, right? But it's automated. And then we also have some automation. Actually, we're going to work on automation to do the same sort of nag script idea, right? You haven't run a Veracode scan in how long? We need to go talk to you. I've already talked about the detailed finding blocks, right? We do hold trainings and e-learning modules for teams. We work daily with devs, and I've been loaned to the containers team since January of this year. So I'm 95% of my time developing. Is a great place to be. And then we have dev days or hack days where we'll take half a day off on a Friday and work on automation. That's been a fantastic thing. Highly recommend it, right? Because you're never going to get the chance to take a deep breath and work on paper cuts unless you iron out that time. And Friday is good because most people are like sick of work and want to do something fun. So that's a great little window. If you can get half a day on Friday, that's an awesome, awesome thing. Key takeaways: automate, 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 like, and make them go away. That is huge, huge win, right? Rinse and repeat. Keep doing it. I fixed this paper cut. I found a new one. Let's fix that one. Finding a workflow, optimize the heck out of it. We're doing pretty good in this regard. It's kind of nice. And I have to do reports, or if I want to do reports, it's a database called a pandoc, right? Done. And create systems that can grow organically. This is hugely key, right? You may not have the final version ever. Have a thing that you can keep adding new checks to, you're golden, right? Because as you find them, like the grep for source code, adding things to look for out of Git, right? It may not be sexy or all that awesome at first, but give it 6 months and it'll be actually really good, right? And you will never have time that it took you to make that over 6 months in one single window, right? So organic, like systems that grow, I won't even start or consider a new system if we can't organically over time, because we'll never have that big block of time. Oh, and I talked about that. Finding blocks become templates over time. And if you don't already talk dev, learn to talk dev. That's hugely important. Oh yeah. Whoever decides constant success must change his conduct with the times. Had to get a Machiavelli quote in, right? It's just it's somewhere. But that yeah. What we end up doing, that's a great question. The question was, what do you do for your longer running tests? I meant to say that, and I'm glad you asked it. Within the deploy window, we just do those. The things that are longer than the deploy windows, we figure out the cadence that works based on the. So maybe they deploy every, like 2 times a week. Well, maybe our long running test takes a week. So we just do those every other week, right? We miss some. We totally miss some. But hey, it's better than not doing it at all. Right? So we just it's really team dependent and what their pace is, but you find that if you know the length of time the test takes and you know the cadence of the team, you can sort of pick that sweet spot where the window, if there was something missed, is as narrow as possible. Yes, sir. I like dumb questions. Oh, interesting. Okay, interesting. So the question was like face-to-face, remote, team dynamics, culture. How does that all work? Rackspace is uber casual. I'm dressed up more formal than I do for work right now, so that's kind of helpful. Rackspace has offices in San Antonio, Austin, Blacksburg, and there's remote all over the place. And then the culture is pretty laid back. So for us. And the one thing, though, I would say is all of the works out of San Antonio. That's been huge because for the security people, we can sort of talk shop and help. And hey, I haven't seen Redis before. You did a Redis on a test, didn't you? Come over and give me a hand. Like, that's much easier if you're all in the same place. But our teams are all over the place. I mean, like weird things like when you book a room for a threat model on a remote team, make bloody well sure the camera can see the whiteboard. Because I had one threat model, I had to draw everything like this, so it looked square for the people on the other end because the camera was at an angle. Right? Like those aren't cool things to go, oh God. And one time we have a lot of glass walls. The camera faced the glass wall, so I just did the dry erase thing on the wall, which was funny because somebody was on the other side trying to wipe it off at one point, which was kind of hilarious. So that racket works pretty good. And I don't know that it's so much like remote, or it's more about like the I don't know how to say this. like putting yourself in the shoes of the team you're working with, right? Because you're in essence saying, look, I found this really ugly thing. And it's not really my problem, it's your problem, right? And I can either lay this on your lap and walk away kind of snickering, or I can say, hey, here's this really ugly thing. Let's talk about how we can fix this. And just be rational, right? You don't have to, like we had a couple interns over in the summer, and they would find, say, cross-site scripting in an internal app that we use to book rooms. Well, that's kind of bad. But if you find cross-site scripting in the, like www.rackspace.com, that's like, oh, holy crap, right? And those different risks, but a lot of times the younger team members don't have that sense of context. Like, this is bad, and cross-site scripting is bad. But in this case, it's not as bad as this case. So let's be a little bit judicial about it and say, look, we need to get this fixed. I know you guys do 2-week sprints. Like, perfect example, there's one of the teams that came to me and said, look, Michael, one of our testers, found these 4 issues in our system. We were able to get 3 in this sprint, and there's 1 that we couldn't get fixed. And I looked at the specifics of the issue. It was particularly hard to exploit. You'd have to have a lot of domain knowledge that isn't really public. So I said, look, you guys do 2-week sprints. Launch, put this in your next sprint, right? I'll come back and test that last thing in 2 weeks. Like, I'm not going to lose my shirt or make you guys work the weekend for this one thing. Like, that kind of mentality. And now that team loves us, right? Because they can have rational conversations about how we fix things, and we're not the like crazy security people who, rain hellfire and brimstone on them, right? Yes, way in the back. He's a plant. Yeah, and like a perfect example of this is one of the times that I did a little happy dance after the team left, or this one guy from the team left is, there was one team that we'd worked at, we'd done an engagement, it was a pen test and a VA plus an API test. We get done with them, we found some stuff, we worked through the issues, great. 2 months later, they come over and say, hey, we want to do this kind of spooky, weird thing, and we think we want to implement it this way, but we're not sure. I'm like, cool, whiteboard over here, let's go talk. And this is like when they're in the paper napkin stage of designing this thing out. They're coming to us to ask for our opinion. Like, huge win, right? That was a very happy moment in my RAC career. Yes?
How do you guys coordinate pen testing?
Yeah, well, that's question. Thank you. I love your thank you. The subtle hints of like, say the question. How do you say that again? Because how do you coordinate pen testers to be effective in that environment? Luckily, all of our pen testers are internal, and it's just a matter of, for our pen testing particularly, those tend to happen in products that are launching in what we call, I don't know what we call it, we've given a name, but preview. It's before customers get on it. So we have access to a real production environment, but there are no customers. So that's like the sweet spot window. But for some of them that are so big, like compute is a silly number of hosts, we do sampling, right? Let's take, in this DC, there are n number of things. Let's divide n by a rational number so we have a decent size and check those. And then if you get variations, then maybe you dig more. But if they all come out the same, okay, good. Their automation is fine. I don't have to worry about it. If that makes sense? So a lot of times because of the automation, your pen testing actually gets easier. Because if I looked at node 1 and node 2 also looks the same, I really don't need to look at node n. Or I might sample a couple of them, but I really don't have to look at the whole IP range, which is hugely valuable. Yes? How do you measure the effectiveness of different security activities that we do? One, we generate reports that managers ask for. I don't know if that's effective or not, but we definitely do that. 2, some of it is just like, honestly, teams approaching us proactively. That's a huge thing. But more of it is like, how many times do we hit those neg script things, right? How many times are teams busting the SLAs? Gives you a really good idea of how effective you are at either communicating and sort of working with those teams, right? If consistently we drop a bug in their bug tracking system and we have to go hunt them down and argue with them, we're failing somehow, right? And that's sort of our metric. Like, how much friction we have to get things. Generally measure that by how many times we're bumping up against that SLA. Oh, interesting. I don't know that we have any metrics to that. Like how long, but like if we launched on October the 1st and we find it on the 7th, that's 7 days. Yeah, I don't think we track that at all, to be bluntly honest with you. We could maybe tease that out somehow, but we never have. Yeah, yeah. So one more time? Do we do design security review? Yes, we do. We call them, I can't remember what, architectural analysis. I can't remember what the on our team who does all of those. And like perfect example, before Kevin and I was doing them, our Hadoop product, not the one that's in production today. But the way they did it is each customer would get a whole bunch of nodes that would do the heavy lifting and the storage for Hadoop. And there was one node shared that would do all the HSQL, the SQL-ish stuff for Hadoop. And we were doing the threat model, I'm drawing this out, and I realized like choke point. And I said, wait a minute, like I just right to buy from Rack. Like I don't need intelligence. And they're like, yeah. Okay, so I have a Visa card that has enough balance to get me a Hadoop cluster. Like, I could write really stupid HSQL queries, can I? And they're like, well, I guess so. I said, so I could like tie up the CPU or knock out this node. Well, I guess so. And I'm like, well, when I do that, I went, oh God. And I went, yeah. And so we actually like stopped the meeting. They went off and redesigned and came back and they'd abstracted all that away and done, right? So yeah, we've done those early. Because if we'd launched that, like, oh my God, fixing that would have been a nightmare. Any more questions? Yes? A separate test org? I report up through the VP of Quality Engineering. So not for me, but yes, we do. Really well, because we're all part of the same org. There's this thing called Cloud Cafe, or Open Cafe, whatever we called it, that is a testing framework for OpenStack. We've actually introduced fuzzing and other tests into that framework so that now the QE guys just do the fuzzing work for us, right? So yeah, like being friends with QA or QE or IVNV or whatever you want to call them, huge win. Like be nice to those people. Because there's way more of them than there will be you, period. Like learn to also be friendly with those guys. Cool. Well, thank you very much. Thank you for making the last talk.